So good afternoon, everyone. Am I audible?
Sir.
Okay. So thank you for confirming. Now, there is a slight change. In fact, one of our expert who was supposed to give a presentation today, he is busy with his work, so he could not make it today. So instead of him, I am going to present one of our work, in fact, in the domain of NLP, what in our lab or what we have done. So I hope so I'm going to present one of the work which we have done in our lab. This is related to cyberbullying and cyber aggression. So I hope that you will really get enjoy this work. So the work what we have done, you will really get benefited from this work, and you will, in fact, excuse me for all the troubles or the deviations what we are making from the original schedule. So I'm really sorry for the deviation, and but I hope that you will equally enjoy this work also. I hope my screen is visible to you.
Yes.
Okay. This one, in fact, here, this work. So I hope now this screen, you can see the presentation where I have this cyberbullying and cyber aggression detection using NLP. You are getting this? Okay, someone has confirmed. So this is a work which one of my PhD scholar had done, and now she is a faculty member in IIT Ranchi. Her name is Kirti Kumari. So on behalf of Kirti and myself, I am just going to give an outline to what we did. As you can see from the title, in this particular research work, we tried to detect the cyberbullying and cyber aggressive events, which is now predominant, very dominant in social media, and how we made a system for that. So let me just, these are the agenda. Before proceeding further, I really I want to make a disclaimer that some abusive words may be present on the slides related to hate speech or cyber aggression or cyber bullying. These words are collected from social media and for illustration purpose only. This is not meant to hurt or offend anyone. The author and his research group never support this sort of activities on social media. In fact, we are against this sort of activities. That's why this work is. So again, I'm sorry if someone is offended by some of the content which we are presenting. This is totally for demonstration purpose. We never support this sort of activity. So all of us know what is an online harassment. So online harassment can be defined as any kind of ongoing torment intending to hurt other online users through electronic media. And one of the popular one is hate speech. So hate speech is an act of insulting, offending, or threatening a person or a group of person or people on the basis of their caste, religion, gender, or similar things. Some examples you can see here. I'm not going to read this. You can see on my screens. These are some of the examples which are collected from the social media platforms. An online aggressive behavior that uses electronic media to hurt others is also termed as cyber aggression. And some of the cyber aggressive tweets you can see, in fact, see here. If the cyber aggression occurs repeatedly, so cyber aggression which is occurring repeatedly and to a relatively powerless person. So the victim is relatively powerless in the sense that that victim is not really say reiterating or basically opposing that one too much. In fact, most of the time we have seen that they really decrease their presence on the social media due to this sort of bullying events. So cyberbullying can be defined as an aggressive behavior in which an individual or group of individuals repeatedly attack, humiliate, or exclude a relatively powerless person. Some of the tweets again is shown here. You can see there is a sequence. We collected some of these are from say tweets. This is from Twitter. A lot of data were also collected from Reddit. So these are some examples. Some other examples which are relatively lesser here, but sometimes they become also stronger is symbolic aggressive. So someone sending this sort of images and writing something. Some unique things also like this, if you see that this is multimodality. I think multimodality have been discussed on this platform in this FDP for a long time now. Sriparna also talked about the multimodality, the issues of multimodality a lot. So what we mean by multimodality here is we have some images, and along with those images, we have some texts, and that's very predominant, very common nowadays on any social media platform, whether it's Twitter or Facebook or even in WhatsApp also, you get a lot of this sort of messages. Now, why I'm trying to attract your attention towards these messages is there is something in this one. If you see the first one, so as it says, so the house is in really a bad shape. So ugly hair, ugly face, ugly house, ugly body is equals to you. So really, both of this, in fact, this house, which is taken as a symbolic representation here, and the text, both are really aggressive, or in fact, you can say humiliating. So both of them, both the modalities are humiliating. They can be termed as both modality, even in images as well as in the text. They are aggressive comments or they are humiliative comments. But if you see the second one, if you look at the image only, if I just hide this portion, this is your best friend. So if you hide this and looking at the snake image only, so if I just send you a snake image, this is a very good looking snake. And that's really a very great image, good image. So if the text content is removed, there is nothing wrong in this image. Similarly, if you replace this image by your friends, by a good looking man or woman, and if someone says this is your best friend, or might be a very cute looking puppy, and if then I write this is your best friend, then this is a compliment. So here, both of these modalities separately are innocent, or you can say they are very compliment. They are never humiliating. But when they are combined, in fact, that gives a totally opposite meaning. And that was the challenge which we really had. In fact, last day also, what Sriparna was trying to say in summarization, this sort of cases, like there may be some scenarios, in fact, where the text itself is good, the image itself is good, but combined together, you will have a totally opposite effect, the opposite meaning, which is shown here. We also did some sort of, in fact, survey, how people are really harassed, whether this phenomena is really worth of researching. That's the first thing in any research I feel has to be done. Whether the problem, what I'm going to research or what I'm going to solve is really worth of doing that or not. So when we started searching different type of surveys and reports across the media, newspaper, different social media sites, different newspaper sites, different survey sites, what we found is a very bad looking, or in fact very alarming situation. So according to Amnesty International Organization survey, they found that 41% of women feel unsafe on social media. You look into this. 41% of women feel unsafe on social media, and 21% of women feel insecure about their family while they are using social media. So they have been threatened not only about themselves, but about their family also. In India, 61% of women get online violence, and 28% of those women have told that they are decreasing their presence on social media due to this sort of online violence. And that's not a very good sign for any civil society. In another survey, we also found that before the age of 18, almost 70% of users experience cyberbullying in some form. And that's the real motivation. In fact, that was the first thing what came to my mind when I thought of doing a work on this one. And I discussed with my scholar that really, because nowadays even school going students, 9, 10, 11, 12, they are hardly of the age of say 14, 13, 14, 15, 16. They are also using mobile phones. They are also uh, say using Facebook, WhatsApp, and so on. And most of the time in our Indian society, even if they are bullied through this sort of online media, they hardly express their feelings to their parents or to their teachers, with the fear that if they told that, if they discuss with their parents, probably their parent will take up their mobile or their say laptop and will not allow them to interact on the social media. So that was the real alarming situation, that before the age of 18, 70% of users are experiencing cyberbullying. And you think of those kids which are really bullied by persons. Uh, they have different names. There are some cyber predators called as cyber predators, and a lot of them in India. In fact, this count is relatively low, but otherwise in developed countries, especially in Europe and American countries, predator is becoming a huge problem. In fact, the single childs, most of the child, when both the parents are in working condition, they are attacked by this sort of cyber predators, and then they are basically exploited in different forms. In US also, 53% of internet users have personally experienced online harassment. And these are the, in fact, links from where this sort of data were taken. And 37% of this 53% harassment were severe physical threats, sexual harassment, stalking, and sustained harassments. If you go into the website and see in cyber predators, you will see a lot of this sort of physical threats and sexual harassment cases to childs, basically teenagers, especially non-adults, kids, 8 to 10 years, 12 years, 15 years. It has also been seen recently that which was studied or which was say surveyed by Patter, that teenagers are making extensive use of images and video sharing platforms like Instagram, Vine, and hence only a solution consisting of text messages will not be sufficient to stop this sort of online harassment or identify this one. And in reality, the cyberbullying phenomena grows bigger and meaner with the photos and video sharing platforms. And recently, it has been again seen, you can see this sort of surveys. Visual content now accounts for more than 70% of all web traffics. So with all these motivations, we thought of how exactly what are the phenomena and how we can, because this phenomena is emerged due to enhancement in the computer system, or basically the online community, and it has been started by some sort of technical persons, the computer engineers. So the solution also has to come from the computer engineers. So how to do that? So we thought of first key, let us define what is online harassment and how far we can look into this. So online harassments can be through hate speech. It can be cyber aggression, cyber bullying, cyber stacking, cyber crime, trolling, and so many. We mainly concentrated on this hate speech, cyber aggression, and cyber bullying in this presentation work. Now, what are the solutions? There are twofold solutions. The first solution is obviously the awareness and prevention, which is a sociological solution. So every school and every parent, in fact, has a responsibility that with their wards, they should discuss very openly, and they should make them confident that if they are experiencing any problem, they should openly interact with their parents or with their school teachers. But this itself is a big issue. It means not every child is same, and not everyone can come forward and interact about that. So the second solution, which is obviously the technical one, we need to identify. So whenever there is a communication, we can identify this one, and then we can moderate, or in fact, we can submit this sort of tweets or this sort of interaction to some sort of moderation people like police or school authorities, or there can be special groups. We can take this sort of say online groups, and then they can probably resolve or counsel those particular victims so that they can really take their life forward. But to do that, they had a lot of issues. Like what are the, in fact, we identified, or in fact, in this particular presentation and in that research, we identified and took care of 4 different issues. The first issue was multilinguality. Like you just go through these 3 sentences. The first sentence is basically the script is English, so it's a Roman script, but the content or the words are from Hindi. So it is written in Hindi. It is a Hindi sentence, but written in Roman script, English script. The second one is written in Indian script or Devanagari script, but it also has some English words. The second one again has some Roman script as well as some Devanagari script. So how to identify that which one is Roman script? So script identification is one of the issues. How to identify the script? Again, I'm repeating script identification, but there are a lot of solutions which can identify the scripts. So that's a very easy thing to do. But sometimes, like in this case, the script, if we do script identification, the script will say that this is English sentence or some sort of European language sentence, but this is not so. So script identification is not sufficient. We have to identify the words, and that's where the challenge was. So we talk about some sort of code mixed, code switch, like this is a code switch content. Like we have some codes in Devanagari and then some code in English and then the whole sentence in last 2. So how to identify this sort of sentences, what can be done for that? The other one, I have already established that one, that we have a multimodal post. So like we have some images and when we have some texts, and as I told that sometimes the images and the text itself can be very good, in fact, but together they can give you a very opposite meaning, very highly humiliating meaning. So how to identify those sort of cases? The third one is writing style of different social media platform is different. Like if you talk about Twitter, Twitter has a word limit. When we started this work, it was 140 characters. Now it is 280 characters. So with 280 characters or 140 characters, so most of the data set what I have kept here is 140 characters only. So with 140 characters, you have a very fixed space to write, very small space to write, and in that small space, you have you really make a lot of grammatical mistakes, lot of abbreviations, and so on, so that you can really tell your content. You can write your content. But on the other hand, if you think of say Facebook, in Facebook you have unlimited spaces, so you can write your whole feeling whatever in one go. But in Twitter you write small sentences and you write several such things. So how to take care? Because if something is developed for say Facebook, that may not work equally good for Twitter. And similarly, if something is optimized for Twitter, may not work good for Facebook, because in Twitter a lot of spelling mistakes, lot of abbreviations, lot of incorrect or incomplete sentences will be there. Whereas in Facebook, this will look like a good English mostly, or good Hindi. So grammatically, the sentences will be most of the time correct. They will have lesser such abbreviations and so on. So how to do that? And the other one was the non-standard abbreviations, spelling mistakes, emojis, how we can take care of this. So these were the main research issues when we started this work. And then we really tried to find out what work has been done that particular time. So at that particular time, we found that till 2017, only English was taken care of. So all of the works which appeared at that particular time, and notably, most of the works were done by Dadbhar and Dinakar. So they were one of the prime forces, or in fact, you can say leading researcher in that field, Dadwar and Dinakar, and most of their work were concentrated towards English. In 2018, in fact, one data set appeared in a code mixed format, and then a lot of work by Bohra, Modha, Gilbux, and so on appeared in 2018. And after that, a lot of other works have also appeared. The content, what we found at that particular time, again, till 2017, most of the works were textual only. So they were only considering the text parts. So tweet content, and most the preferred platform was no doubt Twitter. So people were mostly working with the Twitter platform, and they were using the tweets, the content text, tweet text to do their processing. After 2016-17, people also started working with images. So text plus images, so multimodality came into picture. Most of the earlier works were also again on single platforms, like either it was on Twitter, or some works by Dadwar and Dinakar were also done for the YouTube comments. But again in 2019, 18-19, some data set appeared in one of the conference for multi-platforms like Facebook and Twitter. And then a lot of people started working in that domain also. So that was the status of the work. So with this, all this motivation, we designed, in fact, we identified 4 different sort of objectives for our work. The first objective was to create a multimodal data set. Why we thought of creating a data set? Now these data sets are readily available across the world. So a lot of data set on aggression, hate speech in different languages like Arabic, Hindi, Tamil, Telugu, Kannada, and so many other, Malayalam. They have appeared recently in last 2 years. But this work was started in 2016-17, that particular time, hardly there was any data set. So we first created a multimodal data set for that. Then we designed a multimodal system to identify the sort of aggressive and bullying post. And then we optimized these features using the multimodality, so using the nature-inspired computings like genetic algorithm and particle swarm optimization. And finally, we also take care of the linguality, where we take care of the Hindi and English to identify across 2 different platforms from Twitter and Facebook to resolve the issues. So let us come to the dataset creation exactly, because there were a lot of questions on dataset creations also. Exactly how to create dataset, and as Riparna last day explained, that dataset creation itself, if the dataset does not exist, that itself is a very difficult thing to do. So how we created dataset was because we were going to create a multimodal dataset. So we collected several images across different platforms like Twitter, Facebook, and then some Google searching also we did, and we collected dataset. And then we took, in fact, 3 of our bachelor students, BTech students, did the annotation independently. The annotation has to be done independently. So independently they annotated like the first image, and then independently they had annotated like this is highly aggressive, and the second one medium aggressive, they are the normal post, no aggression in this one. And similarly, we collected, in fact, we collected some text from Twitter, and then we ask our students, group of students, to write some comments which are very similar, because we were unable to find a lot of comments in that field. So we wrote, in fact, our own comments by a different group of students. And again, 3 students did that. Why 3 students? Last day, Dr. Siparna explained that we need to have, like, say, in the first image, the student 1 annotated it as high, second one annotated it as high, but the third one annotates it as, say, medium. Then we can go with the majority voting and we can say that this post is aggressive. But if there are 2 only, and if someone says that this is highly aggressive and this is non-aggressive, then there won't be, we will hardly have any situation or hardly have any option to say whether it is high aggressive or non-aggressive. There can be some situation that on one particular image, the students, the 3 people can go totally indifferently. Like someone can say that this is highly aggressive. The second one can say this is medium aggressive. The third one can say this is non-aggressive. So in those cases, in fact, we removed all those images or as well as the texts because there was no agreement. Say that's where a lot of machine learning engineers, in fact, did not take care of these things too much. Because if human annotators are not, say, agreeing 100% of time, how can we expect a machine to agree or to correctly classify it as 100% of time? That's not possible. No, that's a very common thing. You just think over it that there are certain situations like this case also occurs in medical images. Like given a medical image, say X-ray, and one doctor says that there is say high chance of getting some sort of disease. The other one says no. Then what should be the situation? Obviously, we'll go to the third one, and probably since there is a human being involved, you will do some sort of activity. But there is no agreement. There is the annotator does not agree. So if the annotator's agreement is only say 90% or 95%, then we can never expect that a machine learning algorithm is going to make the system 100%. That bias will automatically come. So whenever we are reporting or we are thinking of our accuracy or performance measure, we need to take care of that also. Like since I worked in different domains also, so I have my friend who is working in speech, and we have a data set called as dysarthric speech, where the people who are not very say good in communicating, जिसको हम हिंदी में हकलाना बोलते हैं, so they stop a lot while talking. So the human annotator, in fact, had an accuracy of around 70 to 80%, 80% something. So machine learning algorithms, if they are giving it 60, 65%, that's a very good thing. So we can at most go up to say that human annotator. In fact, there are instances where machine has beaten the human annotator also, like in case of ImageNet, those who are following different challenges or those who are going through those who go through the machine learning literature, they might have seen that ImageNet, the human annotators, the human accuracy in identifying an image is around 94 to 95%, whereas machine has already achieved 96, 97%. So it's very rare to go beyond that. Again, even if it is going beyond that, who will check the authenticity, that whether it is right or wrong? So after doing all those sort of labeling, we got these many posts. So total images, we had 3,600. Out of them, there were 1,804 non-aggressive, 1,327 aggressive medium, and 469 as aggressive, high aggressive. So this is again, I have already told you that since we had one annotation for images, one annotation for text independently, and then we combined them, and then again we asked the students to annotate them combinedly. What is the label, what they think of? So after that, in fact, these are the scenario you can see. We identified that there's many bullying and non-bullying cases. So image has 464 bullying and 1636 non-bullying. The comment level had 884 bullying and 1216 non-bullying. Combinedly, in fact, the bullying cases increased because, as I have told, that there were several cases where image and text separately were good, but when they were combined, in fact, they were giving bullying instances. So in that case, you can see that the bullying instance has increased here and non-bullying has decreased. And that was the real challenge. Exactly how to write the machine learning code or how to train the machine which can identify this sort of cases. So in first work, that was a very trivial work. We just used a CNN model to identify the aggressive posts from images. So I will request the participants, if they have any question, they can directly ask here. There is no need to wait till the end. I think all of you have that capability to write. I hope so. It's there. Okay, so that was a simple CNN model, and this was the parameter which we used in CNN. There is nothing very great in this one. This was basically some sort of, you can say, image processing sort of task. But this was really something which I need to share with you. Here, what we did, in fact, what I just highlighted so many times, that we have some images and some text which separately were looking good, but combinedly they were you can say, bullying cases. So we tried to find out a representation where we can combine both of them, both the text as well as images together, so that we can really identify those cases. And we tried so many approaches. In fact, in one of the approach which we followed is shown here. So we took a social media post which has two components. One was the image and the other one was text. With the image, what we did, since image was a colored image, so there was already three channels, and we resized that image to 42 cross 42 cross 42, sorry, 3. 42 cross 42 cross 3. So we resized these images because they were social media images. Obviously, they were quite smaller in size. Then we take the text and we represented that text as TF-IDF vector in a size of 1 into 1764. Why 1 into 1764? Because we had the total vocabulary, what we had was only 1764. Sorry, 1764. That was the total vocabulary. So we represented each word with a vector of size 1 cross 764, and then we reshaped that vector as a matrix of size 42 cross 42 cross 3. Say 42 cross 42 cross something. So it was fitting into 42 cross 42 cross 3. Some portions which were left, in fact, we padded them with 0. And then now we have, in fact, you can say that this text is also now will appear as an image. So we have an image and we have a text which is also 3 channel. So then we in fact concatenated these total channels. So 3 channels of images and 3 channels of text. So we concatenated them together one after another. So we got finally 42 cross 42 cross 6. And then we made trained our custom CNN, and that identified the bullying versus non-bullying instances. And this is what we did. So image size, and we use a filter of size 3 cross 3, pooling of size 2 cross 2. The activation functions which were used was ReLU, and at final layer sigmoid, because the last layer was just bullying versus non-bullying. We also use a dropout rate of 0.5 in the dense layer. Learning rate was 0.001. Batch size was 5 because since the size was too big, and with our laptop that bigger size was not able to do that, so we kept it as 5. We use binary cross entropy because at last layer we have to predict just 2 outputs, and we are using a sigmoid. So binary cross entropy will be a sufficient loss function. Optimizer we use as RMS prop, and we run it for 1000 epochs. And this is what we got. So with different one, like with M cross N cross 4, M cross N cross 6, we identified the precision recall and F1 score we got was 0.63. Again, this may look to be a very not a very good say accuracy measure or a performance measure, but considering the scenario that this multimodality at that particular time was not taken care of, so that you can consider this, we can say that this was the first attempt where we made a multimodality, combined multimodality, where we had 2 different aspects of multimodality. So we got an accuracy of around that F1 score of 0.63. So that's what we got. Then we also tried with 1 CNN, 2
Excuse
CNN.
me, sir.
Yes.
I would like to ask a question. Should I ask now or
Sure,
later?
sure. You may continue.
Okay. Yeah. So you have shown very good examples where we have image, which was actually containing some content for harassment, and there was text also. So when you are designing this model, then images are separate and text is separate. So what about those cases where we had image and text together? They were considered together here, and how these were handled?
You want to say about memes, no? Where we had
Yes,
an image and where something is written.
yes,
We have not taken that into this scenario. As I told that,
yes, because it is separately taking images and text.
yes. In that case, even if there would have been certain text, we consider that as images. So the normal memes which appear in Facebook, say WhatsApp, normally those memes also contain some sort of text.
Yes.
We started another work on that, so but that work is not included here. So
Okay.
there was a challenge, and that data set should be available in Coda Lab. So they call that mimetic mimosan analysis. There was a
Okay.
challenge called as mimosan analysis. You can still search if you are finding about data set, thinking of data set. If you have good, otherwise you can go through Coda Lab challenge. There you can get that mimosan data sets. But
Okay.
in this work is not that about that.
Yeah. Thank you so much, sir.
Okay.
Yes, sir.
Yes.
So as per this vocabulary is considered like 1764.
Mhm.
This vocabulary is all from that whatever data is collected from various
Yes.
media.
In our data sets.
Yeah. And there you have reshaped that data, text data.
Yes. Yes.
So that is just to adjust the dimension. That
Yes.
is
Just to
that is
adjust the dimension, nothing else.
okay. And now this textual data must have been stored in some structured form. Is it stored in some structured form or no data storage is there?
No, ultimately, let me just annotate this. Say we had certain text, and every word, if you think, we converted, every word is in the, say, with a dimension of 1764. And if we consider a sentence, in fact, some of the words which are present will be one, others will, because we are using a TF-IDF vector. So it will be something like, not 10, but it will be some number like point. If this word is present, the TF-IDF value of this. If this word is not present, 0. Again, the present, then some value, some non-zero value. Most of them will be 0. Because if we have a vector of size 1764, average sentence length will be say 5 to 10 words. So only 5 to 10 words will have certain non-zero value, others will be 0 only.
Yes, yes.
And then we just reshaped it. We do not, we had not followed, or we have not made any other data structure for that.
Okay. So my representation was like this.
Just this representation was reshaped, just to make a concatenation with the existing image data set, and then
And
normalized everything.
there must have been some kind of ambiguity also in this problem. So any
Yes,
embedding or
yes.
anything?
As I told that this was the first time we proposed something, because that problem, the problem which I am highlighting, has not been, to the best of our knowledge, till now, this sort of problem has not been in circulation or in paper so many times. So that was the first time we identified and we tried to make a system. So we tried so many representation, and then finally we found that at that particular time, this is the best we are getting. Later on in the same work, I will explain that we further extended this work with some optimization techniques, and we could improve on this accuracy with a separate model.
Okay, thank you. Clear.
Okay. So thank you. And now can I move forward?
Yes, sir.
Okay. Thank you. So how to remove this? Okay. So with then we tried with filter size, that how many filters I should keep here, like the number of filters. The size of filter was not of 3x3, but exactly how many filters I should use. We tried again with 256 size filters to 2048. We tried with varying the level of the CNN levels, where I have shown here a CNN. So inside this CNN, we tried to vary the number of layers. So we tried with 1 layer, 2 layer, 3 layer CNN. And then every CNN we try to filter the just size, the increase and decrease the size of number of filters. Not this should be number of filters, not filter size. Number of filters. So number of filters, and we found that with 2048, in fact, we were able to get around 68% of precision, recall, and F1 score altogether. Then we, as I told that, then further we tried to extend that one because that time we also had not very good idea. Then what in the second work, what we did, we took image as a separate unit and text as a separate unit. So we passed the image, as I told in the first day also, that my vision towards deep learning is I always viewed a deep learning model like CNN or LSTM, etc., as a feature extractor. So what I did is I fine-tuned a VGG, and then I extracted. So I passed my image through that VGG, and at the output layer, I took 128 feature. So those who are working in VGG, they know that there will be a number of layers, 16 layers in VGG. And finally, there will be a dense layer, concatenated. And we stop. So normally in VGG, there are 10 outputs. Sorry, 1000 outputs. We restricted it to 128. So we reshaped that final output to make it 128. So we took 128 features from that. Okay. And then we take texts, and then we embedded that text. That example I will show. Last day also, there were questions like how to embed it. So I have a demonstration. I will go through that collab notebook, and I will explain you exactly when I am saying embedded text, exactly what sort of embedding or how we are doing that embedding, what that embedding means. Although that might have been explained, but I will just go through that, only concentrate, highlighting that embedding part. So with a text, TF-IDF, then I embedded it. And while embedding, I made it 30 cross 100 and then passed it through a CNN. And from that CNN, again, here 128 is final output, but we tried again vary it from say 56 to around 1024. With text also, we tried to vary it from say 64 to 1024, and we found that this combination is giving us the best result. So now with this two, in fact, so now you can see that we have an image, a parallel channel. So image, some features extracted. How many features? 128. We had certain text, we extracted some features, and we extracted 256 features. So altogether, I will have 384 features. Combining these two, concatenating these two, we will have 384 features. And then those 384 features, so 384 are binary values. So a vector of size 384. I think on the next slide I have. Okay, so this one. So with 384 features, this is some binary value. So a vector, 384 size vector features. Some of them will be, say, having some value. Some of them will not having some value. So most of them will have some value because this is embedded now. So most of them will have some value. So now what we are viewing or what we are saying is that some of them may be discarded. Out of these 384, some of them may be kept, some columns may be kept, and some columns may be discarded. Now, how to discard? From whom to discard? Because this was concatenated one after another. So 128, and after that we kept 256. So we made that vector. So it was 128 initially from images, and then 256 from this.
Hello, sir.
Yes.
Can you please explain, because I missed my few minutes before, so why there is 256 and 128 features separately?
In fact, we tried all possible combination. This is the final one I have written here. So we varied from say 64 to 1024 as a feature here. And we found that at 128, I am getting the best value. So that's why I kept 128. Similarly, with text, I varied from 64 to 1024. And we got 250, at 256, we got the best performance measure. So that's why we have kept it as 128 and 256.
And one more thing, sir. Suppose if
Yes.
we are having very less size of data available with us, so except CNN, what other things we can use? Other algorithm, machine learning algorithm we can use for this?
So if it is text, you can say machine learning, there are so many machine learning algorithms. So here I am using these algorithms for feature extraction. So if you just really try to find out the target through a machine learning algorithm, any machine learning algorithms like Bayesian net or say random forest classifier mostly gives quite a better result. So any ensemble classifiers you can use.
Okay, okay, sir. Okay.
But here I am not using it as classifier. CNN is not a classifier here. Here again I am reiterating CNN I have used here as a feature extractor. So this CNN is extracting features for me. What we human being extract features, no? We say that okay, number of pixels, correlations, etc., etc. So this CNN is automatically doing it, doing that for me.
Okay, sir. Okay. Thank you,
Okay.
sir.
Okay. Thank you. So let us move ahead. So once that 384 features are there, and as I told, the problem is some of the features may be contradictory to each other, because say the text may be looking good, the image may be looking good, but together they are giving a say humiliating message. So what we thought of, or what was our thought process at that particular time, is some of the features are contradictory. So if we can remove those features, probably we can improve on the accuracy. So that feature optimization, what we are calling it as feature optimization process. So that's how we are optimizing the features. Now we have 384 features. If we can discard some of the features and take only the prominent features. So how we are doing that is we are now taking it as a vector and we are making it as a binary optimization, binary problem. So if I switch on this, that means this feature will be extracted. If I make this off, 0, then this feature will not be extracted. So out of might be 384, might be only 100 or 120 or say 200 features are switched on, rest are switched off. So to get that, we used a genetic algorithm. Now, how that was done? So initially we initialize some population, and the total space what we have is 0 to 2 to the power say 384. So we took certain random samples which we called it as initial population, and that random sample was basically some sequence of zeros and ones with a size of 384. So with 380 size vector, we took some of the vectors. I think initially we took 20 chromosomes. We call it as chromosomes in genetic algorithm literature. So 20 chromosomes, and then we evaluated the fitness. So with those features on, switched on, where there is 1, we are saying that these are the features which are on. I hope this idea is, you are getting this idea what I'm trying to say, or should I annotate or give some examples?
One example is, for example, you take one word and how that vector.
Exactly. Now I cannot take a word because these are not words. So these are certain numbers. Say I'm just making something like
text,
this.
that text you are.
I will explain that what embedding is being done with a Jupyter notebook, ma'am. So please just wait. Here I'm just trying to explain that optimization process, how we are optimizing that feature. So that's how we are going to say. And this length will be 384. So a 384 size vector, we randomly make some of them 0 and some of them 1. And we identified this sort of 20 such initial vectors of zeros and ones as initial population. Here 1 means, say if this is 0th feature, number 0, so this feature is not selected. This feature is selected. This is not selected, this is not selected, this feature is selected, this feature is selected, this is not selected, this is not selected. Then what we do, in fact, if this is 0, so we make all these as 0. So third is 0, we remove them. Basically, we eliminate them from our data set. So we will have a smaller number of features. So instead of 384, now we will have around say 150 or something like 200. And with those 200, we evaluate a fitness. So we evaluate the fitness means we measure basically the accuracy. And then based on the accuracy, we make a selection operation, crossover and mutation, because this is just a binary vector. So easily crossover and mutation can be done. And then we select survival selection is done. And we did it for 100 iterations. And at the end, whatever vector was left, the best vector, so that will have some zeros and some ones, and we are calling that as the final vector. And with that feature, we later on used a classifier, basically. I think. Sorry. Sorry. Yeah. So you can see that this was only the genetic algorithm block. So after that, whatever feature was left, we passed it through a classifier, and we use a random forest classifier. And then that classifier was giving us the Boolean versus non-Boolean scenario. And again, this was basically the hyperparameters. So VGG16, it is fixed. Only thing we changed was the final output layer. CNN we manually trained. And GA again here, the crossover and mutation probability and Rowlett field selection we used. We did it for 100 iterations. And then you can see the accuracy was improved from say 68 to 74. So 0.68 to 0.74. And as I told someone was asking that why I took 128 to 56, that time also I told that we varied a lot to find out the optimal value, which can be considered for this problem. For everyone's problem, this value can be different. I'm not saying that this is empirically examined, basically find out. So for your problem, you can tune this exact at what number I am getting a good result. Sorry, without genetic algorithm and with genetic algorithm. So that's how we move ahead on this one. We did a similar work with another data set, which was again, although these two works are more or less similar. So we had text, then embedding, and then finally here we again empirically did that with another data set. So 512. And then instead of GA, we used a PSO algorithm. So PSO also works very similar to that. Instead of just here, say this sort of mutation and crossover, there you will have PSO algorithm, PSO optimization equations, how these are reaching towards that final value. And normally PSO, the difference between GA and PSO is GA is by default a binary optimization problem. So it will work on this 0, 1. PSO on the other hand is basically a continuous optimization problem. So we had to forcefully make it with a 0 and 1. So we use a binary PSO algorithm. And in that case, again, we achieved more or less similar performance with 74, 74, and 75. Okay, so that was one sort of work we did with this data set. So one was, okay, we combined them. The other one was the highlight of the other one was we separately passed text and images and then combine them and then optimize it. And in both of the cases, with optimizations, we got better results because there were different data sets, different modalities. Then another work what we did, as I told, that multilingual and multi-platform. So this data set was on aggression, basically aggressive data set, and it was published in one of the conference, Polling 2018. So this data set is still available there. So it was a shared task and aggression identification of the first workshop on trolling, aggression and cyberbullying, track 1 at Polling 2018. So in Polling 2018, they published data set which was in English and as well as in Hindi, and they had 3 classes: overtly aggressive class, covertly aggressive class, and non-aggressive class. And these were the data set, and separately they gave the testing data set after the conference was over. So this was the number of testing data set. Here we took a totally different approach, in fact, and that's where again I'm going to explain a bit. Here we used autoencoder. I think all of you know about autoencoders. So autoencoder in general is is something, a network where, which you can say is used to, so this is something like this. Autoencoder is something like this. So it compresses the data set. And then finally it again reconstruct that set. So we as input, so whatever is my input, so this I is again given as output. And by that, this autoencoder is trained. And whatever is left or whatever is the weight here, we can take that as a feature. This autoencoder is widely used in, say, recognizing images and then some sort of intuition detection system. So that's the approach we followed. So we trained an autoencoder, but this autoencoder was not a normal neural network. In fact, every building block of this autoencoder was LSTM. So we have an LSTM. So you can see here, we started with the 100 size vector. Every input was converted because the data set was from Facebook and Twitter. So since Facebook was there, a lot bigger sentences were there. So that's why we had liberty of having 100 size vector also. So 100, then we use 32 LSTM, then to 16 LSTM, then 8 LSTM. And finally, this 8 LSTM, again, we on the opposite side, since this is the opposite side is a mirror image, so we got from, or we increased from 8 to 16 to 32 to 100. And then we try to reconstruct it. Now, once this LSTM is trained, our thought process was again that LSTM can be considered as a one expert. So if one LSTM is trained on, say, covertly with this covertly aggressive data set. So say if I train one person who is trained to identify this sort of sentences. Say another person who is trained to identify this sort of sentences. And third person who is trained to identify this sort of sentence. Then if a new sentence comes, and if I gave that new sentence to all of them, so if that new sentence is, say, energy, this person will make the minimum loss. So the reconstruction loss will be minimum for him. Whereas if that sentence is overtly aggressive, this person will make the minimum loss, other two will make higher losses. So, and based on those losses, I can make our classification. That was the idea. So that's how we trained it. So we trained it again for all possible cases like OAG, CAG, and NAG. But we were fortunate to get that something which is trained with OAG was able to differentiate everything. So you can see what I was trying to say. So a loss distribution of LSTM autoencoder in random initialized embedding. So you can see here the losses are distributed. So this is a loss from one class. This is loss from another class. This is loss from another third class. When we use globe embedding or say fast text embedding, the losses were distributed in this way. So now you can see figure 20 and 21, hardly one can classify something. So the decision boundary cannot be drawn. But in this case, you can easily draw a decision boundary. One can easily say that one decision boundary here will classify these two classes and one decision boundary here can classify this one from the rest one. So looking at this loss, one can easily say that these are now easily differentiable, or say easily classified. And that's what we did. So we trained that autoencoder, what I just demonstrated you. So I trained this autoencoder with overtly aggressive class, and then the losses were calculated, and based on the losses, a threshold was identified, and based on that threshold, we were able to classify them. And we were surprised to get the results. So this is our result. So in general, we got with English, we got precision, and F1 for Facebook, it was in 80s. With Hindi, it was 70. With Twitter dataset, it was in 70 and 58. Whereas, since it was a shared task, a lot of other works also appeared. And you can see the best reported work at that particular time, what others have done into that conference at that shared task was only in the range of 50s to 60s. So the best result which was here was 64 by Erohem and Gilbach, whereas we achieved around 81. Similarly, with Twitter English, best reported at that particular time was 60, which we improved up to 71. For Hindi, very few people have worked. Only Riani, Modha, and Malte and Rataditya have worked. And they have the best work was Malte was 66 on Facebook. On Twitter, he had not worked. Twitter, it was 50. And in all cases, we were able to improve the results. So this autoencoder, in fact, was quite effective in that way.
Sir, can you please explain again your motivation behind this architecture?
This one?
Yes, sir.
So the idea is autoencoder is basically something, as the name says, autoencoder. So we give the input and same thing as the output. So it's we do not need any level data for that. So we had not any level. We do not require, although we had levels, but we do not require. What we give input, same as output. Autoencoder, there is a bottleneck, as I had drawn here. So normally in an autoencoder, we draw an autoencoder something like this. So let me just find out my paint window. Probably then that will be easier. Okay. So say if I draw an autoencoder, it looks something like this. Okay, so this is a completely neural network in general. You can consider it to be dense network. Say.
Sir, we can't see your paint window, sir.
This screen is not visible?
No, sir.
Okay. So stop sharing, again share. Okay, now it's visible. Is it okay now?
Yeah, yes, sir.
So this is how it can be drawn. An autoencoder can be drawn. In autoencoder, we give I, and say as output also we give I. So in a normal neural network, you consider that initially these weights will be randomly initialized. So we give I input and same thing as output. So what will be done? In fact, this network will be optimized to identify whatever input is given to him. Or you can say this particular network will become an expert in that particular input. Right. Normally, autoencoder is used to identify faces. Like if I give an image and then train an autoencoder, and even if I give a distorted input or distorted image to autoencoder, because of these weights, autoencoder will be able to recognize that. Right. That's the normal usage autoencoder is very popular in. To denoise or to basically correct certain images. So once it is trained, so this part and this part, these are identical, you can see. Just these are the mirror images of this one. And this is called as a bottleneck.
Sir, in the background, what exactly autoencoder does?
Autoencoder is a neural network. So any neural network does only one thing, it optimizes the weights.
Okay, sir. Okay.
So there are certain weights, which we call parameters also. There are certain weights. So these weights will be optimized to identify this item. Just a minute. There is a hello. Okay, thank you. ठीक ठीक बाद में बात करते हैं. So now, so these weights are basically tuned. And now if you take the weights here, यहाँ पे अगर हम weights ले ले, so people also use these weights as a feature. Several people also use it as a feature. But in this work, I have not used that. What I did, I tuned this one, so it was tuned. Now the weights are tuned. Now I do not give this one. मैं ये नहीं दूंगा. So I will only give a new input. Any new input. I do not know what input it is. I will give a new input. So if I give I, what it will produce now? I plus I prime it will produce. It will never produce I. That's for sure. Any neural network is not going to produce the real output. There will always be a loss. Am I clear? Do you agree with that? No one.
Yes, sir. Yes, sir.
So this neural network will give, if I give I, it will give I prime. So it's a very close reconstruction of this I, but not the real I. So now if I do I prime minus I or I minus I prime, I will have a loss. And say, if this is the I on which it was trained, then this loss will be minimum. But this I is from some other domain. Say this was trained on I, and if I give, say, K, so what it will produce? It will produce K prime minus, say, K, and in that case, this loss will be higher. That will be higher than this loss. That's for sure. Because this input was not trained, this neural net, this autoencoder was not trained for K. It was trained for I. So for I, it will give the less loss, and for K, it will give higher loss. That was my thought process. That was my idea. Now with this loss, so if I know the loss, like if I train it for a specific purpose, I will get some loss. I will always get some loss. If this loss is low, then probably this is the class on which it was trained. If this loss is high, then probably this is not the class on which it was trained. This is something else. This is a foreign object for him. Okay, that was my idea in whole work. Whether the screen is available now, PPT is available as visible, or should I again? Not available, probably. Okay, so that's what we were doing in that autoencoder. Now, is it okay?
Yes, sir.
Okay.
Yes, sir.
So now that's what that L prime, what L I L K, what I was trying to show. So there will be loss for this some same input from which it was trained, and as you give another input, the losses will be on a higher side. So you can see that this was trained on this input, so the loss is very close to zero. But the other objects on which it was not trained, that losses will be higher. So that's what we are getting. And now if you look into this, if you consider this to be your data sets, you can easily classify them. A simple line will classify them. Any classifier, in fact, we found that a decision tree is working based on this one. Why decision tree is working best? Because this loss is a unidimensional, one scalar value. So for one scalar value, a simple decision tree is working better than any other say classifier algorithms, classifiers. Okay. In fact, in one of our other work where we had many classes, we also tried clusterings. So we did a k-means clustering, and from that k-means clustering, we identified the object because the class was more complicated there. So that time we used clustering. But here, looking at this loss, once we plotted this loss, we found that, okay, a simple straight line will be sufficient for this. And that's what we did. So I think next slide, we have the results. So as I already have results I have shown, this is. So as a whole, to conclude it, and then I will move on to that Jupyter notebook. So there is a need of, in this presentation, I tried to highlight the need of online harassment identification system. Research issues in the earlier system where they were mainly textual, English, and single platform. And we proposed several other platforms. But in this whole work, what I have presented, we never consider any behavioral factors like reaction of victims, hours spent on social media, and so on. That also can be a better clue for this one. In fact, in Reddit dataset, we had some say features available or some sort of indication available for this one. But by the time one scholar finishes the thesis and defends, hardly the supervisor has any control. Now it's up to her to do the work or continue this work. Considered image and text only, but we could have considered other audio, video, URLs, etc. also. We did not use any socio-demographic features like age, gender, persons involved in harassing episodes and their roles. Also, there are so many roles of the individuals who are involved in these bullying cases. We did not consider sequential posting. In fact, we tried some of them. And if someone is interested, they can download the data set which is available in Reddit. That's a huge data set. Almost, I think, more than 10 TB of data sets are available in Reddit. And you can find out a sequential information from last 2004 to 2020 that's available. And we also, as someone had asked, the GIF data or those sort of mimetic data, we did not consider. And we also did not consider any moderation activities which are used. In future, as I told, that we can surely think of using audio, video, or URLs, etc. We can reduce the task of labeling by using, say, one-shot learning or say generative adversarial networks and so on. So that's how it can be extended further. These are the references which have been used in this particular thesis, which I have already referred in the earlier slides also. So thank you for this listening this one and interacting. In fact, more than listening, it was the interaction, your interaction, which makes. So if any further question we would like you would like to ask or discuss, otherwise, as I promised, I will move on to this embedding one, because last day there were some people asking about how to do embedding, and even today also in my slides. Yes.
Sir, in cyberbullying, there are many types, no, sir, like harassment, flaming, denigration.
Yes, there are so many types. So many
But,
types, as I told.
How that features can be considered, sir? It is like the work was like an non-holistic only. There is no work which consider all the features.
No, there is still no work. There is no work.
But how can we do if we want to do that, but the data set is not available, no, sir? How can we work for that?
So say, as I told, if you have considered the highlight of this work, why I presented this work is, or I really appreciate this work is very close to me, is because that's the first time we identified that problem. Cyberbullying was, I'm not saying that I'm the first person who worked in this area. There were people working in other countries in other domains. So that was the first time we thought of, and we highlighted the problem of that issues, like we have different contexts, different modalities. That modality thing we thought of, and we we collected data. We have developed the programs, the models, and published it. So first identify the problems, the issue, what you want to resolve, and you can, in fact, nowadays a number of data sets are available. You can, like this HASOC, this data set, like Coling, this conference, Coling, every year Coling occurs and Coling publishes some data set. FIRE, Forum for Information Retrieval, they publish some sort of data sets every year. So you can consult that. Coda Lab, they have a lot of data sets available. So you can consult those data sets first. If available, good. If not available, then try to create your own data set. That anyway, if we are thinking of working, we have to do.
Sir, but the data set creation, how long it will be like standard one, sir?
So almost it took, I think, 7-8 months for us to create and label all this data set. That was a lengthy process, no doubt, very boring process. No one wants to do. That's the reality.
Thank
so
you
that's
so
why
much.
most of the time we just stick to the data set which is available on the net. In fact, in the earlier part also, that scholar collected and made that data set, but later part, when she got the data set from the net, she sticked her work, or she just did the work. Later works were done on those available data sets only.
Yes. Actually, I want to work in that area, but I was stuck with the data sets.
I can share my data set. In fact, some people have already, I think from South, one from JNTU have already asked the data set. I have shared with him also. Other group from Delhi University, they are also working in this data set. I have shared to them. So whosoever participant want, I can share this data set. There is nothing that this data set is hidden and I'm not going to. I've already shared, but only thing I'm not, this data set can't be put on website, because there were so many, as I told, so many comments which are not good, and putting it on a say common platform or say internet will again raise a lot of questions and lot of unwanted things to us, which we do not want.
Yes.
But any research group, any person who wants to work, I will be very happy to share that.
Yes, sir. Thank you so much, sir.
Okay. So, sir, which classifier is used and can we use manually annotated data? Yes, these are some. The first part was manually annotated only. Regarding classifier, most of the time, say when we develop, so the programs, when first time when a student develops a program, my first assignment is always you take a small data set and you try all classifiers, like start from naive Bayes to support vector machine to decision tree, then logistic regression, then random forest and so on. So they write the code and that code remains with them. So whenever they develop a new one or they even develop a complicated model, finally as a classifier, they test with all of them. And whosoever works best, we normally report that. That's the practice we normally do in our lab.
Sir, my question is, I'm new to this field, so what should be the minimum number of records in a data set used for an appropriate model?
Say, it depends on in which area you want to work. Because nowadays data sets are available.
I have a problem for classifying grievance provided by customer to some public organization. So to make that data set, minimum how many records we should have?
So at least 2,000 to 3,000 data set you should have, because means if it is below that, no, the number of parameters what our deep learning models will have, they will not be optimized properly. Because in a deep learning model, even if you go for a CNN, you will have most of the time you will have lakhs of 2 lakhs, 3 lakhs of parameters to be tuned. And so you can consider even that 2,000, 3,000 is very less, but at least 3,000 data set will start your work.
Thank you, sir.
Okay. So as I told that let us give or go through the embedding layer. In fact, the text. Since I have not attended all this, although I was present, but I was not listening to every. It was not possible for me. So might be all of this information have been already discussed with you. Still, I'm just highlighting this because this is something which is the most important. So ultimately, one thing I know, if you are working with a machine learning model or thinking of working with a machine learning model or deep learning model, ultimately what we need for a machine learning model is some numbers. So, and once the numbers are available, the machine learning code, like someone asked which classifier used, as I told that we normally test it for 5 to 6 classifiers together, because those writing a classifier requires only 3 lines of code in any in Python platform basically. The first line is calling the instance of the classifier. The second line is the fit function. And the third line is the predict function. So there are only 3 lines in a machine learning code. On top of that, there is a huge number of lines required for pre-processing or basically processing that data or converting that data to that format which can be accepted by this machine learning code or which can be passed on as a feature to these machine learning models. And that's where our whole discussion is. So this natural language processing, if you think of working on a computer with a natural language, what we are going to do, we are having certain sentences in natural language and we are converting it to some numbers. That's the whole task. So whole task can be thought of this. That's how I understand. Whether my screen is visible, I think I'm not shared it. So my screen is visible and embedding layer explanation. Let's see exactly what I was trying to say. So this part already everyone knows. Okay, let me share this one, no, so that can have this. And in the evening, my research scholar will show you how this can be say done in Hindi or the other Marathi languages. So I think she have already collected some data sets in Hindi and Marathi, and she will explain you how these things, whatever I'm explaining here for English. And this is the lab, what I have shared with you, this embedding layer. So this is just the normal thing. This has been discussed so many times. So the programs really starts from here. So as I told last day also, so what we are doing, we have an embedding layer. So we are importing tensorflow.keras.layers, and in that layers, even if you are going to create a convolution neural network, the normal dense neural network or a LSTM neural network, you are going to use the sort of layers. Everything is layer there. So there is a layer called as embedding layer. Okay, so we are importing that. So we are importing sequential. Sequential means we are going to make a sequential neural network, and we are creating an embedding layer, calling an embedding layer, then NumPy and array, and then we are having a pre-processing sequences. We import pad sequences. We will see shortly what the uses are. I think this is just duplicate. This has already been used. Embedding also has been already used. Flatten and dense, and then tokenizer. So let us run this. Now I'm just creating here. I can read bigger sentences also, but that will not, because once it become too big, it will be very difficult to explain or basically show you the effect. So I have taken here some small number of reviews. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 reviews I have. In every review, you can see there are 3, 4 words coming into that. And we have labels here, which is the first 5 reviews are positive, negative, which is 0, and the rest 5 reviews are positive, which is 0. Anyway, this label doesn't have any meaning here. They are not going to be used. Just for completion, I have kept it. So if you want to read here, sorry.
The link which you have shared, I am not able to access because it is saying that access denied.
Okay, let me just check it once again. Sharing. How other people were sharing that? Access denied. Bhaskar is there?
Sir, you can download it and put it on a shared drive.
Okay.
Or you can share by link giving view permission only.
Share by link.
On the right top, there is a share button.
Okay, okay, yeah. Right, I was just linking, sorry.
But here important is you should give only view permission. People can download.
Anyone
but
in
they should
this,
not change on your copy.
anyone with the link? Okay, viewer. So this is now, sorry. Thank you, Bhaskar.
Thank you.
So now I think this should be available. Just check once. Okay.
Yes, sir,
So,
got that,
Yes,
sir.
sir. Now it is available.
okay, okay. So now we can go ahead. So first 2 lines are no doubt on your system. So just take your time, just set it up. So I have just created some reviews, which you can see here, and in reviews variable, now we have this. Then I'm just tokenizing it. So I'm calling the tokenizer function, and this tokenizer function is in this Keras. We are taking it from Keras. We are not taking it from NLTK. Okay, that's the difference here. So you might be wondering that in earlier cases like Bhaskar sir or Akshay sir might have given you a different way of tokenizing sentences. Here I'm using this tokenizer, which is available in Keras pre-processing. So I'm using just tokenizer. I'm calling this tokenizer, making everything to lower. And then I'm fitting on this text reviews. Tokenizer.fit on text. So what it does, it tokenizes everything and put it into a vector, or it gives a number to everything. Let me just run this and then just show you. Goes to tokens.
On 7 again.
7 or not one. Okay, nothing coming into this. This is already in tokenizer only. Probably. Okay, now so tokenizer.fit. So tokenizer is a variable in fact, and in tokenizer.fit text reviews. So what it does, it tokenizes things and makes an index. So you can see here tokenizer.word index. What we are getting, all the words. So you see here, never, coming back, horrible service, rude waitress, all this. So first thing is awesome. So awesome, back, coming back. So all these unique words. So let us first count the unique words here. 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11, 12, 13, 14, 15, 16, 17. So there are 17 unique words in this one. Right. Some of the words are repeated like awesome, horrible, I think food also, no food. So these are repeated. Other than that, they are unique. So there are unique 17 words. So now you can see here, every words like horrible has been. So let me just draw this. So you can say that we have created an array like this. So in array, we have 17 entries because there are 17 words. The first word is horrible. The second word is service. This was horrible. The third one was food. Fourth one was, I think I'm not able to now see. So you can see now all these 17 words. So this has got a place in this one. So we have created a vocabulary, and this index we have. So at first index, we have the word horrible. Second index, we have the word service. Third index, we have the word food, and so on. So that's what.
Excuse me, sir. These indexes are being generated randomly.
Randomly, right?
Yeah. Okay. Okay, sir.
So this feed to index, feed on text, that is creating all these indexes for me. We can do it manually also. In LLTK, there is a function. We can do it manually. We can read one by one, tokenize it. We can put it in a matrix. That also we in a vector, and we can do it. But this support is already there in Keras. So we are just utilizing that. I think I have another program where I can demonstrate you manually how we can do it. But most of the time, whenever you are going to work, this is sufficient. We have seen that this works. And so word index will give this one. Then what we are doing, we are trying to find out the length. So if I run the length, we have already counted that was 17. So vocabulary length is 17. That also confirms us that the total unique word in this one was 17. And we have every word coming at one particular place in that array, and total length of that array is 17. Then we are finding out, we are storing that word index into a variable called as word index, and we are converting this text to a sequence. So this was our never coming back. Now, if you see, this neighbor has a index 5. Neighbor was placed in that array at 5th location. So 5. Coming was placed at 6th location. Coming at 6th location. And back was at 7th location. So if I want to represent this, I can represent this by 5, 6, 7. And so that's what we are doing by this one. So we are making this tokenizer dot text to sequences, and then we are passing on the original review. So if we do that, we get something like this, 5, 6, 7. So the first one, 5, 6, 7. Second one, horrible service. Horrible is at 1.
I'm last.
Service is at 2. So 1, 2. Right. So that's what we get. So you can see, isn't it? So now we had certain text. Now that text has been converted to certain numbers. Basically, this is just a representation. Ideally, what has been done, so the first thing is represented like this. So we have, say, 1 to 17 and say 1, 3, 4, 5, 6, 7, 8, 9, and so on. So here we have 1, here we have 1, here we have 1, rest are 0. So this is what we have done. This representation is basically another way of compact way of representing this one. Isn't it? This is just a compact way of representing this. So 5, 6, 7 is 1, 1, 1, rest are 0. So we can write it as 5, 6, 7. Similarly for 1, 2, second one, 8, 9, 10, so on. But the problem here is this sequence cannot be given as input to a machine learning algorithm. What is the reason? Because this sequence is of variable length. First one is of length 3, second one is length 2, third one is of length 2, 2, 2, 1, 2, 1, 2, 4. So somewhere we have to make a mark and we have to make them of equal length. And to make that equal length, we have a function called as pad sequences. So in pad sequences function, we give that data sequence what we have obtained here. So this data sequence as an input. Then the maximum length. What is the length I want to keep it? So what is the maximum length of this text? Now sometimes, so that's why you might have seen in my presentation, I had kept 30 cross 100. So from where that 30 was coming, so I was keeping this max length to be 30. That 100, how that 100 is coming, I will be coming to that. So if you remember, in one of my slides, when I was processing text, I told that I created an embedding vector of size 30 cross 100. So that 30 was, in fact, in my text sequence, on an average, this length of this sequence was 30. But there were bigger sentences also, where the length was more than 30. So what I did, and there were certain shorter sentences also. So let us see the effect on this one and then say. So max length 4, padding. So there is a padding because this length is 3. So obviously to make it 4, I need to add some 0. So we are saying we have a function called as, we have a argument called as padding, and we can make it as pre or post. So if I give post, and then if you print this value, you can see. So this 5, 6, 7 has been converted to 5, 6, 7, 0. 1, 2 has been converted to 1, 2, 0, 0, and all this length is now 4. If you want to make it 3, so it will be done in this way. So last one, you can see that first one is curtailed. Post is kept, earlier part were curtailed. You can make it pre also. So you can see here the earlier parts were curtailed. Sorry, the 0 was added at the earlier part. Okay, so let us make length 4 here and make it post only. I hope this part is okay. Exactly why we need this, because whenever we are passing it, we are going to pass it to any function. In fact, if it is or any machine learning algorithm, if it is not of equal length, that algorithm is not going to accept it or work it. So we have to make it of equal length. So pad sequences, that's where we did it. We make it at equal length. So now what we have? So we have every review is represented as a size of vector 4, a pads a data sequence of size 4. Then now we are going to create our own embedding. That's where, ma'am, what last day some ma'am was asked. So you may please lower your hand. Okay. Okay, someone has given to someone else. So fine. So now I can create my own embedding. So if you recall, or you can put this at the start. So I have called the sequential from Keras model and embedding from Keras model. So here, what you can see here, I'm creating a model called as sequential model. So a sequential model will create a neural network, something like this. So a neural network, something like this, if you are going to create. So this sort of neural network, all of us seen, connected to all basically. Sorry, it's very difficult to draw. So all connected, in fact. So this is a sequential. So input goes from this to last end. So this is a sequential network, one way. So we are going to create a sequential model first.
Sir, what is other than sequential?
We can have a recurrent neural network where the output also comes as an input to the system.
Okay.
Okay. But mostly all these models, because like recurrent neural network or even LSTM, that's a recurrent neural network. But normally we create a sequential model because all the recurrent functions are included in that LSTM. So there also we can use this sort of things. Normally CNN and dense neural network, we use sequential functions. Then we are creating an embedding layer. So as I told, so first layer, so we have to create one layer. So input layer is something, we have to create an input layer and then an embedding layer. So how embedding layer is created? So embedding is a function called embedding. This is the function. This is a variable name. You can keep any name here. That hardly matters. But this is what you need to take care. It has to be as it is. So embedding, the name of that layer is embedding. We give input dimension as an argument here, and input dimension will be vocabulary size plus 1. Now why 1? Because we have only 17 input symbols here. 17, the vocabulary size is 17 only. We have not seen all possible words of the world. It's a very small world phenomena. No, only 17 unique words are there. But while we are testing it or while we are using it, we may encounter a word which is not there, which we have learned initially. So that's why we keep extra one word and we call it as unknown token, UNK. And that UNK includes everything else. I hope I'm clear. Our vocabulary size 17 we have seen. One space, one unknown token we are keeping. Any word which we have not seen here, or even if we make a spelling mistake here, that will go to unknown word. So that's why it's vocabulary size plus 1. So now this size is 18. Okay. So input dimension is 18. And then output dimension. Again, last day the question was exactly what should be the size of my embedding. So that depends on you. You can make it 8, 16, 32. Because this is a small world phenomena, I have kept it 8. In real world, you can go from anything from 25 to say 300. Because like globe, that is available in the format or in the flavors of or in the sizes of 25, 50, 100, 200 and 300. So you can take any number. I'm just taking small number here. You can so that we can see it. And what is the length of the input? So input length is 4, which we have already done here.
So okay. Can you please little bit explore about output dimension? What significance does it have?
Say input dimension is 4.
No, sir. Output dimension. I'm asking about.
Yes, I'm coming to output dimension only.
Yeah.
So input dimension is 4. Now, how we want to represent my final converted vector. So this one, this like whatever I have highlighted blue is here, that will be converted to some domain. Basically, you can say that I have an unknown space and I'm taking my input to that unknown space. So what should be the dimension of that space? Am I clear? Am I able to make you understand this one?
Yeah,
I
yes, sir.
have something. I have, say, this mouse. This is on my table right now. I want to take it to another space. And wherever I will take it, in what dimension I want to represent it? That's the question. So that's user defined basically. Usually, as I told, usually number 100, 200, 50, these are used. But anyway, you are free. You can go bigger than that also. You can come smaller than that also. Is it okay?
Sir, is there any like threshold, like in any fixed criteria that output dimensions should not go beyond
No, no, absolutely. But obviously, if you make your output dimension too big, your every word will be represented in that dimension. So your space requirement will be huge. Your computing time will be huge.
Okay, okay.
Okay. Practically, if that's not a real, say, you can say analogy. I can say this is an analogy only. That's not the real interpretation. Say if I just show this mouse and say that this mouse has certain feature, like it has got a height, it has got a width, it has got a breadth, it has got a color. So it can be represented in that 4 dimensions: height, width, breadth, and color. Say, for example, right? So this is a dimension, like, because this we can see. So I can easily say that this can be represented by these 4 dimensions. What is this 4 dimensions? These 4 dimensions are the features.
Right, sir.
Right. Now, given a word, how this word can be represented? I do not know the dimensions. So I cannot associate a length, breadth, height, color, etc. with this. So the argument is what are the common words along with which this appears? And if there is a unknown feature for that, say feature 1, 2, 3, 4, 5, 6, up to feature 8. So if there are 8 unknown features, I am representing this word into that 8 dimensions of features, where that word will fall.
Okay, okay.
If I am able to make you understand.
Right, sir, right. Okay.
So every word now with that 8 dimensions, every word will have a space in that, will have a location in that particular dimension, right? If you make it 100, so there will be 100 dimensions, and in that 100 dimension, the words will be placed. So bigger the dimensions, you will have more comfortable. Every word will be comfortably placed. That's true. But equally, the processing time and storage requirements will also increase. Okay. So
does it has to take anything with the ASCII or Unicode character sequences?
No, nothing.
No. Okay.
It is not related with that. It is otherwise not related with anything else. So it's a basically abstract feature, some abstract feature. I'm assuming that, okay, my word has got 100 abstract features, and in that 100 feature dimension, I'm going to represent my word. I'm throwing my words there in that 100 dimension feature with the aim that similar words will have similar locations in that 100 dimensions.
Okay.
In that dimension, that space. Similar meaning, similar words, those words similar, they will be placed together in a closed locality.
Okay.
Right. Okay. So,
yes,
should I move ahead now?
Yeah.
Okay. So now I have defined what should be there in an embedding layer, and then I'm adding that embedding layer into that network. So model.add embedding layer. So I have added that layer now. And then I do not add anything else because I'm just going to create that embedding vector. So I'm not adding any other layer. In another program, I will show you how I can add some other layers in the model, and I can do. But wait for that. Let me just finish this embedding part. How you can visualize the embedding. If you can visualize that embedding, no, rest of the things are quite simple. So then, as usual, in a Keras model, in fact, in any neural network, we compile the model because we are creating our own models. The model has to be compiled, and while we are compiling in a model, we have to pass on the optimizer because that loss has to be minimized. So by which, what is the optimizer for minimizing that loss? So we are using ADAM loss because we are using a binary cross entropy here, and matrix is accuracy. ACC stands for accuracy. We can print the model summary. So let me run this one and see. So see here, we have created a model. So we have just one layer in that embedding layer. Output shape is 4x8 and total number of parameters which is coming here is 144. That means this model has got 144 weights total. Why 144? You can count. In fact, we have 18. So go a very bit slower, no? I'm going very slow. It took almost more than an hour. So 18 and here we have 8.
But sir, you are very good in presentation and we are getting much things from you.
8. So okay.
Yes.
18 cross 8 because our input dimension was 18, output dimension is 8. So you can count the number of say parameters here because this will be connected to this 8 and this 8 will also have certain bias B. So 18 cross 8 कितना होता है भाई?
144, sir.
Okay, bias is not taken care here. So bias is not included here. So 18 cross 8. So it is 144 and that you can see the number of parameters here. Okay, this one. So this is 144 parameters. So that's how this parameter is decided. Okay. So this parameter 144 parameter because there are 8 input size is 18, output size is 4, so 8, so 144. So these are trainable parameters. Trainable parameter means the weights are iterated, and so for this 100 iteration it is iterated. So I think we have not given the number of iterations. So it is iterated and then these weights are fixed. Now we are extracting the layer, embedding layer weights. So whatever was the embedding layer, in that embedding layer, we are calculating, extracting the weights, and these weights are basically the embedded vector for the word. So let us extract this. So this is a function embedding layer dot get weights, and then you can see the embedding layer weights. So these are the weights. And if you count, there are 18 such weights here, and every weight is of size 8. You can see here. 1, 2, 3, 4, 5, 6, 7, 8. So this is first one is of size 8. Second one is also of size 8 and total is 1, 2, 3, 4. Total if you count this will be 18. So 18 cross 8. If you want to find out the shape, you can see here the shape is 18 cross 8. And now let us find out the first sentence. So this is how the first sentence will look like. See. Sorry, this is the total weight. Sorry, this is total weight and the first sentence will be this one. So this is the first sentence. Let me just give you a very, so this is say review 1. Review 1 was review 1. Review 1 was this horrible service because this is 0th review. So this is horrible service and this was coded as 1, 2. Okay. And review 4 was coded as 1, 3. So I'm just taking these two as examples to explain exactly what sort of sequence we are getting. So say here we are taking our padded review 1. So this gives us 1, 2, 0, 0. And then now I am going to predict the padded review 1 and we are getting the embedded vector for that. So predict, as I told, with any machine learning model, we have a model.fit and then model.predict. So here we had a fit function. Fit function also. So for embedding, we are not, in fact, there has to be a fit. So there is a predict function. So this predict function, so if we predict, this is what we are getting for the first one. So let me repeat it for all and then predict for one only. Say, this is one. So padded reviews, for all padded reviews, I have predicted the output, and then we are predicting the for first one. So one is 1200. So for one, the word number one, what was word number one? Horrible. So now you can say that word horrible is represented by this one. So that's now the new representation for the word horrible. Okay. So this is a representation for the word horrible.
Excuse me, sir. Sir, I'm wondering that means how without any supervision means how in an unsupervised way the model has learned the weights.
In fact, there will be a, I think I have missed somewhere. There will be order of it, and this will be padded sequence. Compile with target data is missing. Okay. Oh, sorry. Really, here we are. Okay, your question was how we are getting. So this is, in fact, this is called as a uniform embedding. Here we are not doing any learning, right? I will be coming to the other example. Here, this is a uniform. So I have just like randomly, I have split, I have created a space and where I have put the words. In fact, there is no learning. You are right. There is no learning. So how the words are going, but every word has got a space there. That's the only thing it has done. As you rightly pointed, we have not that the target key, similar words should be there in a similar location. That has not been done. But what has been done is we have converted or we have put the word or we have thrown the word into that 8-dimensional space. That's what we have done. That's the only thing we have done here. So you can see what, just let me finish this. Like you can see for one, like horrible is now represented, or horrible has got that 8-dimension space. If you consider, it has got a location of minus 0.024, something like that in all 8 dimensions. Now, similarly, if you see for padded reviews 4, it is 1300. And if you again predict for padded reviews 4, you will get a similar value. So you see for 1, this value and say this value. These two are same. See, yes, it's smaller. So you can see here this value and this value. These two are same. That means that ensures us that every word that horrible is going to that same location. So it has now got a fixed value for that. So it has got its own location in that 8-dimensional space. It's initialized with random values, obviously. Okay, it has not learned anything. So that's how we can create. In fact, I have another example. I think in that example, we have how we can learn this. This is one way, our own embedding. The other one is by Globe. So if I want to create using Globe, so Globe already is a matrix you can download. I have already, it's there in that database. So with this, we are writing each line. So Globe is basically a matrix where every word has got certain values and then there are dimensions. So 25 dimension. And then we can word line by line, we can word this. So in Globe, we have these many word vectors in Globe. And total size is 6 billion and size is 100 dimensions. So out of those 100 dimensions, I am taking 25 only. So embedding dimensions, I'm fixing it to 25. and then I am reading out from that. So these lines are available even in the globe side also. And again, we are making a sequential model, but instead of instead of training it, we are making this trainable false. So if I make this trainable false, so then what we will have the network created, but the parameters won't be trained. Since the parameters won't be trained, in fact, it will not, so it will take the value, sorry. It will take the value, let's run. Run, I think. Third index, where is the problem? This is so. And then again with this, you can see here the trainable parameters were 0, so we do not need to train it. All are non-trainable. And again with the similar arguments, if we run it, now you can see that for the first word, so the shape is now 18 cross 25 because we have every vector is represented in 25. And so if I predict, say, globe 0, predict 0. Now this one you can see there are 4 words. 4 words.
ये टाइम मेरे को प्ले ऑफ में सुजल को दे दिया फुकट का सुजल मिला ना मेरे को वीरेन का अच्छा है ना मारते एक टाइम पे तो खेलता है वीरेन का नाटक होता है
Excuse me, please switch off your okay. So now you can see
Hello, Mr. Prudvi Goyal. Unnecessarily, you are disturbing the entire session. Will you please mute yourself, or shall I ask the coordinators to expel yourself?
what's the name? Prithvi, no? Prith. He is already mute. Okay, so okay, let me share this. So now you can see the only difference is there were 4 words, and now each word is represented in a dimension of 25. So here instead of 8, now we have 25. And again, if you just make a similar check, that same word will have same sequence. Every time it will be coming into that. These are already trained vectors, trained weight. So we are just reading it from that globe matrix, and this value is already available from the website. You can download it, this one, globe.twitter.27. This is for Twitter, and for others there are bigger one also. This site is quite big. So this is the way we can really deal with that. Really, we are dealing with. Now, once we have, say, as I was talking about, say, now these are numbers. So once we have numbers, so we can fed it to a machine learning code. So any machine learning code, we can fed it. Let me just quickly give you an example. And here I have that training also. So again, let me check. I think whether this data set has been discussed with you, the spam collection.
No, sir.
Okay. Anyway, we have our session only, so let me just take some time, and then probably that with Hindi and Marathi, we will go on. So just let us finish this one. Okay, so we have a data set here. Just show you some spam collection. It's a very popular data set, freely available.
Can you show us the code for that LSTM autoencoder and usage of these word embeddings through that?
Okay, LSTM auto, I need to search that code. I do not have readily available right now because, but I can surely, I think, let me just give me this today's night to find out and get that code.
Sure, sir. Yes, sir.
Or
That will be
tomorrow,
a means and great learning for us.
tomorrow I will just show you that code. At least I will share it with you and give a brief explanation exactly what we did. So whether this screen is visible to you?
Yes.
It's SMS spam. Okay, so this is the data set. So you can see here in this data set, we have certain SMSs basically. The first part is label. These are spams. And these are the data sets. So with this, my notebook is visible to you.
No, sir.
The problem actually removing every screen. Okay, so now it's visible.
Yes.
So
Yes, sir.
just it's a simple reading. So we are reading it through a panda frame, and then the separator is there is a tab. So it's a tab separated, and there was no heading on that. So we are giving a heading from our own label and messages, and we are reading it and just displaying the first top 5. You can see here. So this is the label ham spam, and these are the messages. We are again segregating them into 2 variables called as text, and the second one is class level. So from this data frame, data label will be in class level and data message will be in text. And then you can print this class label and text separately. And now what we are doing is we are in fact converting it to a one hot encoding. So this label is converted into one hot encoding. One hot encoding means this ham. So we are keeping say ham. So this will be represented in this fashion. Second one is ham. So 1 0. Third one is spam. So this will be 0 1. So this is how it will be represented. This can be one representation. The other representation is just label, and then the first message can be represented as say 1. The second one can be represented as 1. The third one can be represented as say 0. So this is one way. So this is normal representation, and this is called as categorical representation. So I am going with a categorical representation because in several neural network cases, it will be better to have a categorical representation. So I am just using a function called as toCategorical, and then we are classifying, or we are just, they are classes ham and spam, and we are making it as 0, 1. So you can now see here 1, 0, 1, 0, and so on. Then these are simple NLTK can be done with the NLTK also. But because we are already importing Keras, so we prefer to do it through Keras only. So everything is done through that Keras. And now you can see the vocabulary size here. I'm not just going to explain all those things, fit on text and then word index and then text to sequences. So you can see here again the indexes. These are the places where the words are coming. And then you can find out the first sentence, which can be represented by these numbers. So 49, 471. So these are the different words which have come. And this is the 0. So you can find out that go is basically at location 49. If you go into this sequence, you can find out go is at 49. So it's the same thing what I explained with a smaller data set. Then we are padding it, post padding, making it a fixed length. So the length here we have kept is 32. So everything is now converted to 32. And then I am splitting this data set into two parts that also I have explained one day. So we are converting it into train, test, split. So all those message padded sequences will be, some portion of that will go into extrain and some of them will go into extend. Corresponding will go into labels, will go into Y train and Y test. And then we are creating the model. Now that's where I need to just devote some time. So again, we are having a sequential model. We are going to use dense, dropout, activation, flatten. So all these can be say taken or imported from the layers, embedding, and then convolution, global max pooling 1D, max pooling 1D. And then we are also using a function plot model just to give a pictorial saving of that data set. So here this is the model creation I'm doing. So I'm creating a sequential model, just like previous case, I am giving an embedding vector. So embedding layer I'm adding, then a convolution 1D, then max pooling, then flatten, then dense, and finally dense with 2 output neuron. Why 2 output neuron? Because my label you might have noticed that I have converted into categorical. So it's 0 and 1, ham versus spam. So there will be 2 nodes, one node for ham and another node for spam. And activation I'm using is softmax. Then I'm compiling this and summarizing the model summary you can see, and then I'm also plotting it so that you can see the real model. This function is also available. That's why I have imported this one. So even this plotted model can be used in the paper also. So you might just download it, save image, and you can even give it in your paper, etc. if you are developing a paper. So these are the total numbers. Someone asked me what should be the minimum number of say data set. So you can see the trainable parameters here. So at every layer, the first layer, embedding layer, you have a trainable parameter of 90,000, I think 9 lakhs 1,000. Then convolution, we have 38,528. Then in dense layer, then dense 1. And so total is this one. This is the model. And here we are now calling the fit function. So that's why someone asked me, sir, that embedding I have not trained. So basically embedding is individually not trained, but now you can see that whole model is trained. And so obviously that embedding is also being trained there, right? This whole model is trained. Embedding is a part of that. So that's our own embedding. We are not using any others embedding. So that's our own embedding. We are training it. So let me just run this one. So I'm not run the earlier one. Let's test. I will start different something. Class level, then level, and speed processing. Private sequence. Then we have the splitting, then the model, the fit function. So this model fits, so that I'm just running it for 2 iterations only. So now you can see this model has run for both the epochs.
Why are you taking the den size 256 there?
Which one?
Final at the output there dense is 2. Dense layer
Yes.
size 2. But just
Output is
before
only
that there is 256.
So that is again your own defined. So basically we are creating a model. We have to now come down. So we are embedding, then once we convolution ends, no, then we flatten it. Now when we flatten it, it is too big sometimes. So from too big directly you can come to 2, or you can in between you can create some more layers, dense layers, and come down slowly. You can come down to 2. Okay. So that's the reason. In fact, initially when we flattened, we have 768. And so from 768, instead of directly coming from 768 to 2, we are coming it down to 256, then to 2. But that's again user defined. That's nothing. There is nothing.
Why can't we come directly to 2?
Yes, you can directly come to 2.
Okay.
There is absolutely no hard and fast rule that you cannot directly come to that.
Okay.
So we just try to include. Say, if we include one more layer, so if that inclusion of one more layer gives me more flexibility in terms of some more nonlinear functionality will be added, and sometimes it can behave better. That's one of the argument you can say. But theoretically speaking, a neural network with one layer is sufficient to do anything.
Okay, sir. Okay.
Okay.
Okay, sir.
So, and now we can make the predictions. So model.predict. So now, as I told, model.fit, model.predict. And then once we make the prediction, no, the predictions will be, because we have last 2 layers, and those 2 layers we have softmax. The softmax will give values for both of them. That means that will give a probability. So for like the output will be something like this. In this case, neural network, the output will be like say 79 and 0.21. Say for say like the ham it is 0.79, for a spam it is 0.21. In some cases it will be say 0.1 and say 0.99. So something like the output will come something like this. So what we do then next we make a argmax function. There is a argmax function. Argmax. So argmax function will return you the level or the position where this maximum value is occurring. So it will give you say 0 in this case. This will give you 1 in this case, and then we really make out. So that's, you can say, the prediction test that argmax 1. So argmax will give you that final level, like level 0101. That level will be done. So you can see here, that's what I was trying to say. So it will give something error like some error, say output something like this, and then we
Sir,
finally.
could you please explain the concept of argmax again?
See, when you make predictions, no, because there were 2 layers at the output layer. Sorry, 2 nodes, 2 neural network nodes at the output layer. No. So there will be a prediction for both of them. The network is going to make prediction for both of them. So the output, the final prediction will look something like this. This is the prediction what I have just shown here. Say this today in different also. So this is the prediction. So like for first prediction, for first case, this is one value. So for upper neuron, say 1 neuron, this is the output. Second neuron, this is the output. Say this is for ham and this is for span. So for ham, the probability is higher. For span, the probability is very low, as you can see from these numbers. But these are not 0, 1. So you cannot compare it with the real level what you have, the real test level what you have. No, this is not that same value. This is, you want your output to be in terms of 0 and 1s, not in terms of certain probability distributions. So argmax basically gives you a position where the highest has occurred. Wherever the highest has occurred, it will make it 1, rest it will make 0. So that's what, if once we apply this argmax, the result comes like this. So it was maximum here, so this is 1. Minimum was here, so this was not maximum, so 0, 1, and see, you can see. Now is it okay?
Yes, sir. Thank you.
Once we have this, and then we have the real target. So real this y test. Let us print this y test here. This is prediction test. Now prediction test is this one. And then you can print this y test. So your y test is something like this. Now you can compare these two. You cannot compare this one with this one. Right? So that's why this argmax is required. This y test array, this array cannot be compared with this array. This can only be compared with this. And how to get this from this? We need to have argmax. We need to pass, or you can make a threshold. If it is, say, since this is a 2-class problem, so you can also make a threshold. But since we have a function available, why to use our own effort? Let us use that function. Okay. And then you can check the results. So I'm just checking with a very toy example with just 2 iterations. You can see here. Yesterday also, ma'am, I think Namita ma'am, yesterday only, she explained a bit about precision recall, F1 score and support, micro average, macro average, weighted average, sample average, etc. So this is the measure we get. Okay. Is it okay?
Yes, sir. Yes, sir.
Yes, sir. Thank you.
A small question is there.
Sure.
Sir, suppose if we wanted to train these word embeddings in an unsupervised way, so what changes would have been made?
Unsupervised way means?
Because in this example, we are having the labels, spam or not spam.
But this embedding is not based on that labels. Embedding is a representation for the text. Okay, there is nothing supervision in that one.
Sir, I think those labels have been used for training these parameters, and embedding are also.
To be very honest, no, this embedding, in terms, if you ask me, I will never suggest you to use your own embedding. The problem is, as I told, one part of embedding is okay, I will take my word to a higher dimension. But the other feature this embedding should give me is this word, say word X, if I'm putting it to a location, if there is another word Y which is very similar to X, Y should also get a place which is very close to X. But in this embedding, whatever I have done, I cannot guarantee that. So this is a toy example. I'm not saying that this is a research one and this can be taken as an example. That cannot be guaranteed. Whereas the embedding what you get from Google, like Globe or Fast Text, they have trained their model with all the text of Wikipedia and 80,000 literature texts. We can never match that.
Right, sir.
Right. So it is advisable that you first try with that. If for your language, if a model is available, then that's the best thing you can do. Because that's more authentic, people will accept it. If I say that I have done my own embedding and then in that own embedding I have done something, people may raise questions. How much data you have taken to train or basically create that embedding space. And we can never match with Google or Facebook or Microsoft to say to basically to compete with them. Right.
Right, sir. Thank you.
Okay, so let us stop here for the first session. And
please, so please share this collab
this
file.
one. Okay. Right.
This database also, sir, please.
Database. I'm sharing this one, but the data set, I think I will keep it in that drive. That data set will be given. Anyway, we will create all this. I think we are already keeping this. Today's lecture presentation I have already kept. The only thing is some of the video, some of the lecture notes are still not, we have not yet received from the expert. We are regularly following them up. So as soon as we are getting from them, I will surely upload it.
Sir,
Yes, sir, because the
presentations are
Today's presentation I have already pasted in that Google Drive link. Let me just share that Google Drive link also again.
Sir, last 3 days this is not available. Presentation in Google Drive.
No, presentations, all presentations are not available, that I know, because the presentations are not with me. But before say talk, the experts are not giving the presentation. We are persuading them rigorously by presentation. Give me presentation, but you know everyone is too busy. So just give me some time. I'm persuading them. Even they have not sent their their honorarium form also. So it's very difficult thing. The difficulty is not to arrange this sort of seminar. The difficulty is really getting all those sort of say what to say, those slides and everything else from the expert. NLP lectures here. Let me just share this. Get link. The link, copy link. So this is the link, I think. This is the link where we have kept all the videos and whatever slides we have available. Even today's slide I have already copied there as day 9. And just after finishing this one, after 5 to 10 minutes, I will upload all these data sets and everything else there. Okay. This data set. Spam.
So when the next session will start?
Just take up 5-10 minutes.
So we can take a break now.
Yes, 6:35 will start.
Okay, thank you, sir.
Okay, data set I have already kept in that drive, and this has been shared with you. So if someone wants to try it again now, they can try it. Okay, so thank you.
Good evening, everyone. Sir, can I start?
Yes, Kunjan, we can start, I think.
Yes. So today I am discussing about we are discuss about the Marathi language data set and Hindi. So now first I am going to show you the data set. So this is the Marathi data set, and it is a news data set in which we are reading the text and then try to identify that which one is having positive sentiment and which one is having negative sentiments. Here two things in the data set, tweets and label. Tweet is the textual text in Hindi, and label is the like -1 and +1. -1 for the negative sentiments and +1 for the positive sentiments. You can say that there is the two types of labels in the data set. So it is a news data set, and now we will generate an embedding on that data set. So actually, I have already shared the data sets and codes in the shared folder, which whose link is has already shared with you, and you can use the data set from there also. I have shared the Hindi dataset and Marathi dataset both. So now I am going to implement this code on the Marathi dataset, and you can also do the same as for the Hindi. So first we have to, you know that we have to mount the Google Drive on the Google Colab. So I'm doing this, and after that we have to path that folder where the data we have kept and paste it here. And in the last session I have in the last demo session I have also explained you how you can mount how you can copy the path for that drive. So where is your data set is saved, you can go there. I have saved my data. This is the folder. So I have right click on that and copy the path and paste it here. After typing cd, so after that we have to read the data set, and for this I have to import the pandas library and numpy for the further we use this library in the further code. So my data set is we can read this we can read the data set, and our data set is in the CSV format. So you can write pd.read_CSV and you can pass the file name, and then we get this. So while we can also print, and you can also call that data, so we can see that there is the 12,114 rows and 2 columns. The column is tweet and label. So and then we are keeping the text data in the text and labels in the label. Yeah, and then we actually in this code I am going to generate the embedding for this data set using the GemSim. So first we have to import the NLTK, and we are using the package here is the pump package for the, and tokenizing the data. So you can see that the tokenized send and word tokenized for the index I2 up at that many I is the index of the text values. And so I'm showing you when we are we want to see the tokens which is generated by these is like this. These are the tokens which we have generated. Now now I am using the generate. I am using the I am going to actually I am going to generate the embeddings from the these tokens. So we have to import the JSON, that is first, and then JSON.model.word2vec. Actually, I am using here the word2vec because for the Hindi and other languages we have the word2vec and globe, as in the previous session. Sir has already explained how we are using the globe model for our embedding. It is only used for the English data set, and the word2vec is also used for Hindi and English, both of the data sets, and some other languages also. So I'm going to generate the embedding for the word2vec. Sorry.
May I ask a question?
Yeah.
Ma'am, for Marathi or Hindi, stemming and lemmatization is not required in this case?
Actually, stemming and lemmatization.
Yes, ma'am. Because for English, we that in like pre-processing itself, we stem the words and then lemmatize the words. So for word2vec, I'm just curious whether for languages, our languages, Indian languages, is that required? Is that step important?
Actually,
The stemming and lemmatization, no, wherever there is an inflation upward in terms of that, in fact, Hindi and English, Hindi and other Indian languages, they require more effort in this sort of stemming and etc.
Right.
Because here we say, karta hai, karti hai, things changes, no?
Yes,
Basically,
exactly.
these are same words. So stemming
Right.
refers to making them into similar context.
Right.
So stemming and lemmatization in Indian context is more important.
Yes.
Okay,
So,
they are more important.
But sir,
And that's where, in fact, most of the problem in Indian languages are.
yes. Yes, exactly. That is my query because I am also working for Indian languages and using NLTK stemming and lemmatization does not work because those algorithms are only made for English words. So they just cut the words and it does not make any sense when those words are stemmed. So of course there has to be another different approach for stemming Indian.
There are two possible. Since means the problem is we do not normally, we have not worked extensively in Indian languages.
Oh.
So I really cannot say how much facility is available in that.
Okay.
One thing is you can search if the facility is available, okay. Otherwise, you can think of what means a lot of works can be done in that field only, how to stem a word in one of the regional Indian languages. My suggestion will be you visit either IIT Patna's website or IIT Bombay website.
Okay.
Because Professor Pushpak Bhattacharya, in fact, in this workshop also we tried to invite him, but he is not in India. Otherwise, we are very eager to invite him because he is a person who had done a lot of work for the Indian languages, especially for Bengali, Hindi, Marathi, and so on. So my suggestion will be you visit his group.
Okay, sir.
Bhattacharya sir's group.
Okay, sir.
And one more place is IIT Hyderabad, or IIIT Hyderabad.
Right.
So
Sir,
their
is
work group is quite good.
sir, is there any way to connect with Pushpak Bhattacharya sir? Because also I am also trying to connect with him, but I don't know how to connect.
So that's why I'm suggesting now. He was very close to us once, but now he has left IIT Patna. He is in
Okay.
Bombay, and right now he is not in India, as he informed me when I contacted for this workshop. Otherwise, I would have started. The first version of this workshop was started by him only.
Yeah.
So, but since he was not available, you visit his website. His PhD scholars are there.
Right.
Or even you can write it to Asif and Sriparna. They were very closely associated with Pushpak sir.
Okay.
And in fact, Asif also has done a lot of work in Hindi and other Bengali. Hindi and Bengali, I know. So you can, and as far as my knowledge goes about Asif, he is very cordial and he will surely reply. He or one of his students will reply. So you can contact Asif first.
Okay.
And if support is there, he is knowing everything about the Pushpak sir's lab. He is very close to them. He was his director. Pushpak sir was director of IIT Patna. So he will be the right person to, tomorrow Asif will again give a demonstration session. So I will request you ask him and you ask him to share some of the resources.
Okay, thank you so much.
Thank you, sir.
My group and in fact myself also do not work too much in Indian languages. We are mostly in application domain, but they have worked in hardcore domain like this one, stemming, grammatization, dialogue systems, and part of speech tagging. So they have developed a lot of this. They had a project also for Indian languages.
Right. Yes, sir.
Connect with them. Visit IIT Bombay, IIT Patna, connect with Asif and even the scholars of Pushpak sirs who are in IIT Bombay. They will surely reply you.
Okay, sir. Thank you so much.
Thank you, sir.
Okay. So Gunjan, please proceed.
So, one question is there. It is possible with the Telugu language. Yeah, I said it is also possible with the Telugu language as well. Um, so we are generating the embeddings by using the Gemsing packages, and I want to visualize this. So we have used the PCA and reduced these components so you can visualize it. And I will show where the embedding is generated for the some words. So it is so dense we cannot able to visualize it, but you can also reduce their data samples, and if you can generate the embeddings and you want to see, it can also be possible. And only we can able to see that there is a Maharashtra written, so it is for the Marathi language. So something related to the Maharashtra is close to, and these are the words which is not related to the Marathi, matlab in particular for the particular sentiments of Maharashtra. So these are, you can see that these are apart from that. And I want to show you some embeddings which was generated. Right. First, we will the this is generated. So I have written the, you know that the word to get Marathi at 100D, that is the, and it is a text file. Here, the embeddings of the data is generated. So you can see that first is for the comma and, for the dot, then Ahi is the in Marathi, and at the rate, whatever they have generated the tokens for that, they generated the embedding also. And just a minute. Actually, let us see embeddings for the main. So you can see that for the every word, there is a embedding is generated and size is 100. If you count, then you can able to find out that there is the total hundreds. The size of the every embedding is 100. So for the every word, it is generated. Now I am going to use this embedding to in the sentiment analysis of the Marathi text only and classify it in a multiple class. So now I am going to show you that. Okay, this is the same. You know that every thing about how to import the drive and how to go to that folder. Now read the Marathi data set here, and same is the process for the you can able to take a variable tweet in a text and class labels in the class label. So and it is I am here. I am using the using to categorize categorical function because I have to find out the number of labels. Actually, first I want to show you the date. Okay, sorry, it is a Marathi dataset which I have already shown you, and we know that there is the two variables -1 and 1. So -1 for the negative sentiments and +1 for the positive sentiments of the comments. So there is a category. We are using the categorical function to find to categorize. Here I am. We are using 0 for the -1 and 1 for +1. It is considered like the first data first label what it get. It's considered it as a 0 and next one is as a 1. So now we are using the tokenization process to tokenize this into the tokens, and after tokenizing this, we got that the 60,934 tokens, and it is, we can also say that it is the unique so we also take it as a vocabulary size, and it is showing, I am showing this the tokens for the 0th the 0th comment, like this one, for this one. So it is there, and while I am passing it to the text, then you can see that for this is only we get that tokens. Token, sorry, we index of that tokens. Sorry. And we are using the Keras reprocessing sequence, and actually we are doing here the padding because we know that all the sentences in this data set is not equal. So the generated when we are doing the embedding and we are generating the embedding for the every sentences, they have different length. So we have to pad this, and we are doing the post padding. It means that on the sentences, and after that, if actually sir has already explained just now, if we are taking the sentences of we are considering it as the embedding vector length, the sentence length is like 5, and we have a 3-meter sentence. So for that, we have to doing padding and then making it equal to the other sentences. So it will put geo after after the number which we have which we have got from the tokens, and after that, like in the last sentence, you can see that after this we are getting the 0. It is due to this because we are doing the padding. If we will not do, then it will not seem like this. So after padding the documents of 0, we can see that it is that much, but before padding it is a different because their length is different. So if we are fixed that sentence, that length, and if the sentences is less than that fixed number of length, then we are adding the 0, and if it is more than that particular length, which then we are curtailed it, but we have reduced and fixed it up to only that much we required. Like here we have taken as a 32, then if any sentences or any embedding is more than that, then we cut it from at that place. So now we are using the, actually here I am using that retrain that embeddings which we have generated from the GEMSIM. I am using this. So I have copied the path from that documents like this, you can see. If anyone is having any doubts, you can ask. Yeah. What to have Marathi. So I have copied the path from here, and you can paste it here, and then you use this embedding in to embed your data set again, and after that you got that a total 8,421 word vector in that, in this embedding we generated, and after that we fixed that the embedding dimension as 100, and we generated the embedding vector. Now we have to, after generating the embedding vector, I have to pass it from to any model or any classifier, so we can able to classify it for the negative sentiments and for the positive sentiments. So first, for that, we have to first split it. So we are splitting these documents into the training and testing. In that documents and also label, we are going to split it. So after splitting it, we have using the we are using the sequential model, and the sequential for this you can see that there's a input dimension, so it is a dimension of the total vocabulary size. We got that, and it is a vocab size, and the output dimension we are going to fix it as 100, and here's the embedding matrices which we have got from the embeddings we generated from this code. So it is actually we are going to implement the CNN. So first is the first layer. Like you can see that here is the embedding layer, and just sir has also explained it about this. So we have, can anyone tell me how we are getting this? No, okay. Actually, our vocabulary size is, please everyone note it down, 60934. Okay, so our vocabulary size is this. And we are getting these parameters from where I am going to explain this. In the first layer of embedding layer, we have that much of neurons, and we want a output as 100. Because we have 100, and when we multiply with that number of neurons with the 100, we got that this, and then these when embedding is done, then we come to the convolution layer. So actually here I am using the 1D convolution. You can also use 2-3 convolutions also, and here I am going to explain how this is working. First, we generated that, and after that, if you pass the sentence from that nuance, there only that many of the nuance is active, or we can say that only that many of nuance is active as much in the first in the first embedding in the embedding of the first sentences, that many of words is already that nuance is going to be active, and then it is passed to the next. So here I am using the filters, 128 filters, and kernel size, which is the size of 3, and activation function is value. So in the 1D conversion, how we get these parameters? So we get these parameters actually when, hello, can anyone tell me how we are getting this? Okay, no. Then I'm going to explain. When we multiply the number of filters into word dimensions into a filter dimension, and there is also some bias, because when you are you know about the neural networks, having the biases also. So that many of neurons is there, and that amount of bias is also there. So there is the 128, so 128 neurons is also there. When we multiply and add the 128, we get that amount of parameters. And then after that, we have doing the max pooling. In the max pooling, we get, now we have only the 30, the size of my conversion is 30, and we are using the max pooling. While we are using the max pooling, and the max pooling size is 5 here. You can see that. So the max pooling is doing in the 1 dimension only, not in the 2D dimension, in the 1D dimension only. So while we are applying the max pooling over that, so we know that there is the 30 is the size, and we are applying the max pooling. Then how many of matrix? What is the matrix size for the next input? So then it becomes applying 5, 5, 5. Then we get that only the 6. So after, and again there is the 128 filter we are using, but there is no parameters. It is a max pooling only. So it is minimize the size of our vector, and then we flatten that layer of after max pooling, we flatten the layer. So we have 6 into 128. Actually, we having this vector size of 6 into 128. So if we flatten them, then it is becomes 666 for 128 times. So 6 into 128, and we get that much of the neurons. And after that, we have a dense layer. So in the dense layer, we are using the 256. You can also use 521, whatever, how much neuron you want, you can use there. And then there is that amount of parameters we got. And after dense, in the last, actually, how we decide that how many neurons in the output layer? Here we have only 2 labels, so that's why we are using the we are using the 2 neurons, and then we pass it through the softmax, and we got that the output. So that I have explained, and there is a trainable parameters. That amount, if you summarize this, then you got that it is a trainable parameter, and non-trainable parameter is this. So what I have explained in here, that is also explained in this. So now I am going to fit after applying the models. You can say that now we am going to fit for it for the training. So I use the X train and Y train, and validation set is our X test and Y test, and epoch is 2, and batch size is 100. And so epoch means we can say that when whole complete training set is executed from that models, or you can run it from that model, then we can say that it is a epoch 1, and here is the epoch 2. So we can say that the whole data set can be used in the training at 2 times. The same data set is used at 2 times. So it is epoch 2, and batch size, actually the whole data set we cannot pass it to the model while training. So we are pass it in a batches. So here is the 100. We have distributed the data in a 100 batch and pass it. First go the 100, then next 100, then next 100, like this. So after training, we have to we got that predicted model in the predicted we have after training we are going to predict it. So model dot predict x test, and the prediction test one is like the prediction test one, and we actually sir has already explained that the argmax function where I'm using, because sir has already explained that if the value is one is higher and one is lower, so we have to find the probability and you can do manually it. But if we have a function you can use, and we got that. So which one is the higher value? That one has got the one, and next one is so 0. So those value which is having 1, it belongs to that class.
Can you tell something about this verbose argument in cell number 23?
But sorry, where?
Actually, this verbose, when it is running, the model is running. So whether you want to see the outputs, what it is doing. So if it is 0, it will not show anything. It will silently run. If it is 1, it gives you certain messages. If it is 2, some other more messages it will give. So we have to see that what is called as.
Okay, sir. Understood, sir. Thank you.
The concern arguments. But verbose 0 and 1 are mostly used. 0 means we are not seeing anything, and 1 means we are seeing. 2 also has some like this callbacks, etc. also is shown. In 1, it will not be shown.
Okay.
So it will not show you epochs like epoch 1, epoch 2. This will not be shown. Finally, result will be shown to you if it is 0.
Now we come to the after the predicting the data, and now we are going to find out the classification report, and the classification report is we have to pass the test parameter and the predicted parameter, the originally test what we have, and what we predicted from the model, and then we got these parameters, so precision recall and F1 scores we got from here. So this is whole about the word while using the GEMS Marathi language classification using the GEMSIM, and also I want to show you about the Hindi language also. So give me a minute.
Sir, so meanwhile, can you tell us some good sources or links where Hindi data or maybe some other Indian languages data is available?
Actually, you can also get it from the Kaggle, and the sir has already said say about the HASOP. Actually, it is and Coda Lab. They are always doing some competition or so, and they are releasing some data set. Most of the time, these data set is in the not in English language. Most of the time, it is in Hindi, Malayalam, Telugu type of data set they are releasing. So you also get it from there. So actually, this is the Hindi data set that downloaded it. Okay. Uh, This data set, first I am talking about the data set. It is a Hindi data set and it is a movie review data set. In this, we have three type of labels, 0, 1 and 2, where 0 is used for the negative sentiments and 1 is used for the positive sentiments and 2 is used for the neutral. Okay, so and we have can I show you again how we are generating the embeddings from this Hindi data set, or I can only explain the CNN how we are using this data set to classify the sentiment of the movie reviews using CNN. Hello.
Show once again, please.
Okay. So here I am going to generate the embeddings using the same Jensen packages and on the Hindi data set. So we read the data set from using this pandas library, and again we take the text into the text variable and labels where you can see that label is in the experience of that data set. So we keeping it in a label of our label in the label. And same again, we are using the NLTK and pump packet to, tokenize these Hindi data set. And after tokenizing this using the Jensen packages to convert it into the Hindi embeddings. And here I'm using doing this. And same we have to. You can also visualize it. It can be possible only when I run it. So I can show you how to visualize. Let me give me a yeah, now I'm going to show you. Yeah, you can also see it is also some dense, and I have already told you about if you generate a using the Jensen package, if you generate a small embedding for 10 or 20 or 100 data set, then you can easily visualize it. So after I want to show you the generated embeddings in the Hindi language. Yeah, you can see that it has also the dimension 100, and here I am generating the it generated the embedding for the every tokens like K, hai, may, something like this, and also get the film. And if you count, it is of 100. So whatever word in your data for the every unique word it generated the embedding. So I have already shown you for the Marathi also, and this is for the Hindi one. So now I'm going to I am going to classify the this Hindi data set on the basis of their textual sentiments in the 3 different classes. So the same here we are using the CNN for classify this. First we will have to import it, and then we need the data set, and then we store the text into the text and class label and the labels of the data set into the label. Okay, and here I am using the actually you can see that in the Marathi dataset, it two category is categorizing in only the 2, 0 and 1, but you can see that it seems clearly that we have if you actually we have the 3 type of labels, so it is two categorical is categorizing in the 3 you can in a 3-into-1 matrices for all. Actually, for the where it is 1, it belongs to that class only, and that class only. So it and sorry. Yeah, where it is 1, it belongs to only that class. Like first one is, you can see that its label is 2, so it is 0, 1 and 2. So here is the only 1, and the second one is 0. So there is in the place of 0 we got 1. So you can see it, and after that I'm using the Keras reprocessing to import the text tokenizer to to generate the tokens from that textual from that text, and we generated it. So, and after that we have to know that the vocabulary size, so that many of the unique unique words in that vocabulary is the vocabulary size, and here you can see that the same as at the index 0, the sentence is this for this number for that sentence. Here we are generating the generate here you can see that the index value of that generated tokens, and it is the our text first first text sample. So I shown you, and their corresponding tokens is there in the previous one. So after getting the tokens, we have to create the embeddings. So here I am creating the embedding and fixing its size of the 32. So we got, and those samples which is not having the 30 size of 32, so it can be after padding it become every sentence or every generated embedding become 32 only. So after that we have seen, we actually I'm going to use that generated Hindi embeddings. So I'm copy the path for that generated embedding and paste it here. But you can, if you want to use the Grove and Fastix, you can also use this. Just I'm showing you how we can generate their own embedding for a particular data set and how we use it. Actually, sir has already explained in the previous session that you can how you can use the pre-trained embeddings are available below and Fastix, and you can use it here also. So we are, I'm using our own generated embedding, and there is the total 7,095 vectors of 100 dimension is here. We are what we have generated in the using the GEMSIM. So now we are going to fix that the dimension of the embedding, it is the 100, and after this we get the we are going to, on the basis of that embeddings, we are going to generate the embeddings of our data set, what I am using here in the above. And after that, after generating the embeddings of from that, so now our actually when we are going to pass the parameter, we cannot pass the as a text as a input of our model, so we have to convert it into the vector form, and for this we are tokenizing and we are doing embeddings, and after that I have to pass it in the model. So for this we have to split it into the training and testing, well, what I am doing in this. And the size of my training is the total number of data we have, that 30% is used for the testing and other 70% is used for the training. And here I am using the keras and sequential model and activation, whatever we are using for the like activation function, and we are doing the flattens and dense layer, so that we have to import so everything here. And we are doing the convolution one-dimensional, global matrix pooling one-dimensional, whatever we are using in our model, we have to first import it from the keras layers, and then we are going to first embed these the generated embeddings. So first we have to use the input dimension, which is equal to our vocabulary size, and the output dimension is same 100, but you can also change it, no issue. And the input length, and it is trainable or not, so it is going to trainable is here is the false, and we got that. So can now anyone tell me how we get it? Hello? In the last, Marathi, while I am classifying the Marathi dataset, at that time I have already explained it. Can anyone tell me how we are getting this?
Yeah, the total number of unique words were this much and multiplied with 100.
Sorry?
The total number of unique words in Hindi that in this data set were 23269, and those are multiplied with this 100 value.
Yeah. And for in this also, you can say that how we are getting this. It is for the embedding first layer, which is the embedding layer. And now, while we are doing the conversation, can anybody tell me how we are getting this? Okay. So once again, I am going to explain you. Yeah, I will surely. Actually, I have already, uploaded all the documents in the link shared by the sir in the previous session. So you can access all the codes and data set from there also. Okay, so first in the convolution layer, actually we have 128 filters we are using, and the size of the filter is 3. So we have to first you can you have to understand that here actually the total numbers of words in the embedding layer is embedding me. Actually, we have fixed it. You can see that here embedding dimension. It is 100. So and if there is the and if there is the 100, so 100, so the first 100 word is if coming, and if we are applying the filter, and total number of filter we are applying is 128, and the size of the every filter is 3. So if there is 128 filters and every okay, and we have a dimension, embedding dimension. So there is the 100. So 100 is the embedding dimension. So we have to multiply it with, and it become 128 into 100 plus into 3. Actually, the filter size. And after that, actually we have biased also, because in the neural network, you know that the neurons layers have the bias also. So we have a same number of bias, and it is the 128. So 3 into 100, 3 into 128 into 100, and we got that amount of at that, and plus 128, we got that much of the parameters. Okay. So now the max pooling. The max pooling is come to the max pooling. In the max pooling, we have a dimension of 5, and actually it is a 1D. So we have only the vector of 1 into 5, and we applying these in the this over that 30. Okay, so well, we are applying the 30. Total we have the 30, and we are applying the max pooling over it is the 5. We got that that 6. So we got it 6 from here, and again the filter size is 128. So we get, and then after that, after max pooling, we are flattening the layer, because we are using the one layer convolution. And after flattening it, we got the total number of 768 neurons at that. There's also one dense layer. So in the dense layer, we are, after 768, we are using the dense layer, in dense layer 256 neurons, and then after that, actually here I'm using the 3. So 3 why? Because we have a total 3 type of labels, and for the soft, and we want the three neurons and the layer of our model. So that's why I am using here the 3, and which is 3. So after this, the softmax function will pass it through the softmax function, and then we got it. After that, we have to compile that all the models what we have. Model.summary, and thus whatever I have explained ever, that is explained in this, in this. So now after creating, we have to do training. So for the training, we have to fit the model with the training data set. And here I am doing the training for the 10 epochs. How much epochs or how you want to, you can. But you know that while you are learning anything, and you are learning repeatedly, or after sometime continuously, then you can remember anything easily, and it is a good training, we can say that. So it's need we train our system more and more, and it is a good. So we can you can also increase that epoch size as much you want. Now we have to fit the text data to predict that for the prediction of our label. So after doing this, we have a prediction in the prediction test. What we have predicted, you can see that here in the prediction test.
क्या आ रहा है?
Someone is creating noise. And it is our prediction test. So what we are getting from. So after getting the prediction report, we have to use the classification report, and it is also called the confusion confusion matrix. So we are to know the classification report, we are pass it to the test data and predicted labels or this, and we got that, and this is the our precision recall and F1 scores what we get for while we are classifying the or movie review data set in the 3 class of sentiments what we have get. So anyone is having any questions? The output shape none, 32 and 100 indicates. Actually, I have already explained. Can I, or you understand, or can I explain once more? Hello.
So I have a
Continue,
question.
Gunjan.
After seeing the means prediction accuracies and all the scores that we have printed, what can we say means about the goodness of the word embeddings that we have learned from the word to vec model?
Can you repeat your questions one more?
Yes, sir. Can you just scroll down to the last cell in which all the results have been printed?
Yeah.
So after seeing these all scores, what can be said about the goodness of the word embeddings which have been learned using word to vec model?
See, actually, we can see that this is not performing well because these data set, we can say that with the CNN or actually we are implementing the only, one layer of convolution. So it is not performing well, we can say that. But if you want to improve, sir has already, explained in the previous session, you can tune your parameters with the data set. Because many time if for this data set is not performing well, but for the other data set it can perform better. So actually we have to tune so in the tuning we have to adjust the the parameters of the CNN what I have already explained here. So we have to tune all these like what is the dense layer size, what is the filter we have kept the filter size is 256. If it is perform better, then it's good. So overall we can say that seeing the result, it is not performing well because the accuracy is not good. Okay, but you can fine tune it and give the better result also.
So what will be your first step towards the improvement of this model? What will you try first?
First, I can improve the kernel size or change the filter size, and then see what the result I'm getting. Or also we can change this also. And the next thing, one thing also, here I'm using the one conversation layer. I can use the two conversation layer. Maybe it perform better.
Yeah, okay. Thank you.
Okay, anyone having more questions?
Yeah, I have one question. Am I audible, ma'am?
Yeah, you can.
Yeah. Okay. So for this word embedding was done on proper text. Like this text does not have any spelling mistakes or any such problems. But suppose I have a text which has a lot of spelling mistakes. So in that case, the word embedding would not be properly set. Is it so?
Actually, actually, as much I know, I think
No, actually, for example, suppose I am translating a speech document to text document. So, for example,
okay. In this, I am generating the word embedding. You know
For
that.
text speech to text, no,
yes,
there are different ways.
no, sir.
Normally,
My question is that a proper sentence like "मुझे अब घर जाना है," so that is a proper text that I have. Now, when I have this "मुझे अब घर जाना है," now I am putting it, feeding it into an ASR, and instead of "मुझे अब घर जाना है," we get something else. The text is something, "मुझे अब घर" is something else, and "जाना" is something else. So basically, we have "मुझे अब," and "घर" is a wrong word, and "जाना" is a wrong word.
use markup model. So
Yes, sir.
basically, after you transcribe the speech,
Yes.
so whatever you get, then we pass through a language model.
Right.
And then language model based on the those markup models, no, what Gadhar Pradhan told the first day, second day in fact. So through that markup model, we see that what was the previous word, and based on the word, what will be the probability of the next word,
right,
which is coming. So that is called a language model. So we do a language modeling here.
Okay. So my question was that if I skip this language modeling and directly get that wrong sentence to generate an embedding, will that result be?
No. Normally, that will not be a very good option. Your best option is as soon as the next word is being generated, we pass through a language model and we get a problem complete sentence.
Okay.
While generating that language model, like while you type something on your keyboard, no?
Yes.
It gives certain suggestions. So it works on similar principle.
Yes.
Based on certain characters, it predicts what can be your next character or what can be your next word. So that's way, and for that language modeling, we can use an LSTM model or hidden model to do that.
Okay, sir.
Okay.
Okay. Thank you so much, sir.
Hello, sir.
Yes.
Yes.
You have explained that embedding, that is how it is created, etc. Now, in that, it is recommended that glow or fast text kind of we should use. But whatever vocabulary we have, so first our vocabulary that we first have to create the embedding on that, and then we can go for glow or fast text. No.
No. We create padded sequences. That example I gave you, no. So you create padded sequences. That means your sentence representation in terms of those vocabulary. And then you can always create that embedding layer, even if you are not willing to use a glow or that is not available in some cases. Then you can use that embedding layer and you can directly pass on those padded sequences.
But
the system will automatically.
Yeah, but it will not give the model compatible with Glow. Like embedding will not happen like Glow. So
No, these are two options. Either you can go for your own embedding or you can go for Globe. And Globe is only available for English. It's not available for others.
But sir, we can use Glove and this Word2Vec for training also, no? If we have our data like in this case.
Word2Vec you can use for training, not Globe.
Okay, okay.
In Globe, you might have seen that the program I had written, I have made that trainable false. That means the Globe model you cannot train. If you have to train, you have to use that Word2Vec.
yes, that only I wanted to ask. It's for
Globe
training.
cannot be trained. Globe is already trained.
Yeah, Globe is already trained. So first one has to use Word2Vec and then trainable false and then go for Globe.
Once you do Word2Vec, you can always create your own vocabulary. Then you do not need to go through Globe again.
Okay. Okay.
That is another option. That means if there are not, say, in all possibilities, you are not only going to work with English, even with code mix texts, Globe will not work properly. Because Globe is trained for pure English sentences. So
Yes.
even if you have another language for which embedding is not available, then the only option is you use this Word2Vec model and train your own embedding vectors. And then you create something which is very similar to Globe. And then you can make a lookup from that table and you can do further processing.
Yes, sir. But just one thing I want to add upon this, like means nowadays at least many complex models from Google such as BERT as well as some precedents to it like Elmo, they also do exist, which I think we can.
They do this embedding. They do this embedding.
Yeah. So I
They are
think
instead of Word2Vec, you can go for newer models like Elmo and BERT. They have more language facilities, and they can, even with smaller data set, they can give you a better embedding vectors.
Right, right. Thank you.
Because they are already partially trained.
Yes, sir. In fact, means I think pre-trained word embeddings for many
Are
languages
already there. That's what I'm telling you.
already
So they are
there.
already trained. So
Yes.
fine-tuned. Basically, what we are saying as training is basically fine-tuning. So with our own language models, with our own languages, with our own text, we are fine-tuning and we are finding out the weights.
Yes, sir. So, sir, this sentence of yours just clicked me a question, sir. Suppose we are training the bird for, let's say, Hindi language. Means I just want to know the process. How should I fine tune them?
So basically that training. So when we are training, in these all these models, there are several parameters, as I have already shown you through that experiments, that there are several parameters. Now, last two layers or last one layers in all these are transfer learning examples. So in these cases, you can keep some of the like last layers normally is again we train it. We assume that initial layers basically are similar for all the languages of the world. And say the last 3-4 layers are specific to our own cases. So we make those last 3-4 layers as trainable and earlier ones are non-trainable. So training occurs in only those 2-3 layers. So whatever back propagation occurs, that occurs only in last 2-3 layers. So only those weights change, and finally when you read, so you will have a totally different weights. The output will be different because some of the, even if a single weight change, output will be different.
Right. Last layers
So
we
that's
can.
what we say by fine tuning things.
Okay, sir.
And that occurs with any cases, like whether you are using BGG16, whether you are using ResNet, all those CNN models also, or pre-trained LSTM models, we do the same thing. We just trained the last 2-3 layers, depends. And again, there is no strict rule that I can train just last layer or last one layer, last 2 layers or last 3 layers. You can train the whole network also. But unfortunately, most of us do not have that resource to train that. In our lab, we cannot think of training a 16 layer or 19 layer network. Even if you have a GPU, the time it takes, it's sometimes it takes more than months, 2 months, so that you cannot wait with those data sets. So that's why it's better to train smaller parts and see your performance. If not happy, then probably go one more layer and then see. This is what the experimentation we do.
Sir, what about what is your opinion about INLTK package in Python? INLTK, I have found that they have some.
To be very honest, I have not used too much that INLTK. So today itself, in order to demonstrate you, I tried that, but it was not working well for me. To be very So I also need some time to be very confident and say something boldly about you. Okay, this can be done.
Yes, sir.
Again, those models, those most part of those INLTK, no, you will see that they have been developed by Pushpak Bhattacharya and his group.
Yes, yes.
So Asif will be a perfect person to get some more idea about that.
Okay, okay.
So I will request tomorrow you ask this question and hopefully Asif will answer.
Yes,
He will answer better than me at least.
Right, sir. Okay. Thank you, sir.
So thank you, Gunjan. You may continue now.
Okay, sir. So now I think anyone having more questions? Actually, sir, I have completed the coding part. What I have to explain.
Excuse me, madam.
Yes.
Please, could you share your link and dataset?
Yeah, actually, I think you all have got the link. Once again, I am sharing. Wait.
Can we leave this meeting if there is no more content to show?
Yeah, if you don't have any questions, you can. Okay, this is the link for this particular one, but I have already shared the the documents, I mean data set and the coding of what I have explained you today. In the link, what sir has shared a link of the Google Drive. I think this link is there. Yeah, once again. Yeah, this is the link, and if you go there, you can see the all the content of the today sessions in the day 9. I think folder name is NLP FDP day 9. Okay.
Thank you.
So anyone can have any questions?
Okay, so it seems there is no more questions from the participant. So we can wrap up the session here. JP, sir, are you there, JP sir?
Yes, okay, sorry, sir. Actually, yes, you can know the everything in the not in the day 9. I think the folder name is NLP FDP day 9. You get all the content from there.
Okay, then good night, everybody, and let's wrap up the session. I'm
Good
ending
night,
the
sir,
meeting here.
and good night, everyone.